This conference will now be recorded.
Yeah, hello everyone, and welcome to day one webinar of data science and data science. Since I hope everyone is here and we have a lot to cover, we really should begin today's webinar. I really appreciate you all for attending today. A very good morning, afternoon, or evening to one and all present here virtually with me today. Let me introduce myself. I am Razina Els, Conference Secretariat at Coalesce Research Group LLC, and I will be available for any of your queries and questions throughout the webinar to help you out technically and organize the webinar successfully. For the next 5 minutes, please allow me to give a brief description about our organization, College Research Group, and also for the further instructions. College Research Group LLC is very delighted to welcome you all the speakers, supporting associations, students, and delegates present virtually with us today. With the aim mark the scientific excellence by facilitation conversations, sharing knowledge, College Research Group follows through the objective of setting standards in delivering excellence in the research among the researchers, academicians, and industries, promulgating the research through conducting events and online webinars from various fields of science, especially from the stream of medicine, science, engineering, and technology. Within a short duration, we have succeeded in creating a platform for developing a strong professional network with the people across the world from their respective fields that they haven't connected in a while. As a global scientific event organizer, we plan and carry out international conferences, meetings, seminars, symposiums, and workshops providing the best delegate experience, excellent networking opportunities, conversations leading to innovations, learning new opportunities, lasting working relationships, and professionalization within the professionals around the global network. Just recently, we have also started our own platform for open access, peer reviewed scholarly literature, where all the content is freely available without any charge to the reader. We aim to share the new recent advances through scientific publications, which will help in minimizing the borders and contributing the use of research works of eminent authors, scientists, researchers, research scholars, students, etc., across a broad spectrum of medical, clinical, pharma, and engineering scientific disciplines and its subspecialties to promote the ideas which will guide the development and facilitate the use of scientific information and ensure its quality, and also will be the connecting link between researchers and scientific community. We are committed in ensuring that our journals are disseminated worldwide so that the researchers are able to access our content whenever and wherever they need it. As being a very few journals, we have coined up some interesting journals and have also formed the editorial board and will be very glad if any of our today's attendees, the speakers, students, or delegates, could extend their support by checking the journals and will be interested in publishing our inaugural issue according to the area of expertise. We will also send an email with all the details about the journal after the commencement of the webinar. Do take your time to check the website. Finally, I would like to thank to all the attendees and participants of today's webinar titled Second International Webinar on Big Data Analytics and Data Science, and hope you will enjoy the webinar and gain knowledge from the sessions too. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the sessions, I guess some of you will be new to the GoToMeetings app. Let me just explain you the important tools required for the presentation. On the GoToMeetings app, or web page, you can find four icons at the bottom of your screen, that is mic, camera, screen, and end button. Mic, click on that to mute or unmute yourself. I request you all to stay muted while our speakers are presenting the research work so that it doesn't cause any disturbance to them. Camera, you can use this button to share or unshare your webcam. If you have the option to share the webcam, you can do it, or it is completely your choice. Screen, you can use this button to share your screen. This is the main part. During your presentation, after I call your name, from my side, I will be making you the presenter, and only I give the permission, you will be able to share your screen. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. And this is your fourth icon where you can use this to leave the session. On the top of corner, you can use the options to change your display settings. At the top right corner, you will have a three icons. That is people, chat, and settings. In the chat option, you can chat with me or any other participants. For the settings, you can use this button to check for the settings of your speakers and microphone. So as mentioned, kindly remain muted during the presentation so that our presenters don't get disturbed. And for any questions, you can ask the questions or you can send your questions in the message box too. Well, let's not take much of your time. Finally, I would like to request you to please give a brief description about yourself before starting with your session so that we can know about you virtually. And now let's move into our sessions. So our first keynote sessions is presented by Dr. Khalid Al Sadi from King Abdullah University of Science and Technology, Saudi Arabia. And I will just give a brief biography of Dr. Khalid Al Sadi. He's a leader that with 30 plus of years of experience in engineering, project management, asset management, facilities management, system modernization, and oil refining industry. He is committed to enhancing profitability through execution of long-term strategies that cover technology, transformation, and sustainability. A team player, results-driven with exceptional interpersonal and negotiation skills, who is an expert in identifying opportunities, initiating new ideas, and driving them to implementation with excellent communication, facilitation, and representation skills. And the topic of keynote presentation is predictive analysis. Hello, Dr. Khalid. Are you ready with your presentation now?
Good
Hello?
morning and welcome to all. Yes, can you hear me?
Yes, I can will to hear you. Yeah,
Okay.
are you ready with your presentation?
Yes,
Okay. Can I know with which name you have joined the session?
my name, Khalid Sadi.
Yeah, just a minute. I'm making you the presenter. Yes. Yes. Now you can click on the share button and share your screen with us.
The file is not coming into your screen. So maybe the entire.
Yeah, did you got the pop-up to share your screen?
Yes.
Okay. Ye-
Can you see it?
Yes. Yes, perfect. Please make it a full screen and start your presentation.
Okay. Good morning, all, and welcome. Happy Labor Days to all of us. And hopefully, today we're all going to learn something new through this webinar. I'm a computer engineer. I graduated from California State University in 1995. I hold 35 plus years of experience in project management, asset management strategy, facility management, and system modernization. Most of my years experience, 25 years experience is in Saudi Aramco, oil industry company. And then in the last 12 years or 11 years, I moved into KAUST, King Abdullah University of Science and Technology. I'm a founder of IoTech company in Saudi Arabia. I'm also the representative of the Orion E global company. In the subject that I would like to talk to you about, it, I'm going to cover the predictive analytic, talk about the definition, the process, common method, models, and the tools. Then I'll take you through a case study that we have implemented in CAUST, and then I'm going to summarize my presentation. So many definition that we have on the internet, on the Google, on everywhere you go, there's a lot of definition about predictive analytics. I have picked this definition. I thought it's simple, easy, and it can always give the whole meaning of what we needed to do. It is a practice of extracting and using existing data through strategic techniques, be it statistical or data mining or machine learning, to predict unobserved or unknown event based on the historical data. When the goal is to go beyond knowing what happened, is to predict what's coming or what could be happen in the future. Similar to any smart devices that coming into the market or assets in general, you connect it, you monitor it, you collect the information, you plan it, you fix, you redefine the data, you analyze it, you change those span point, you improve it, you execute it, and you keep doing that. Predictive analytics, it's almost the same. You define your project, you collect the data, you clean and prepare the data, you build up the model, you test the model, you redefine and deploy the model, and monitoring the result and keep doing that as well. When we talk about the method, purely there is it's all about machine learning, and there is a supervised learning and unsupervised learning. And the supervised learning, it's a machine learning approach that defined by its use of a label dataset. These datasets are designed to train the algorithm into classify data or predicting outcome accurately. Using the labeled input and output, the model can mature the accuracy
Hello.
over the time. Yes.
Yeah, hello, Dr. Khalid. Can you please move forward your slides? Like you need to move the slides for your explanation. Yes. You can make it a full screen so that
Okay.
it will be easy. Like,
I am doing it full screen.
okay, okay.
Okay. So the supervised learning can be separated into two types of problem when data mining works: classifications and regressions. The classification uses the algorithm to accurately assign test data into a specific category, such as separating apple and juice for apple and orange, for example, or what we are using on the email when we define a set of rules that taking the spam email into a separate folder. While the regressions, it's another type of supervising learning method that use algorithm to understand relation between dependent and independent variable. And that's where we are going to do the case study that we have implemented in CAS. So when we talk about the model, basically it's a template that allow user to turn past and current data into an actionable insight and creating a positive long-term result. Predictive maintenance model focus or forecast the change to essential equipment breakdown. Quality assurance model spot and prevent defect to avoid disappointed and extra cost when providing product or services to the customers. There's so many tools again that helps on doing predictive analytics. These tools give a user deep and real-time insight and almost endless array of business activities. Tools can be used to predict versus type of behavior and patterns. In our case study, we have used SkyPark predictive tools software. Um, some, I would say, some features that came built in onto the Sky Spark. I don't know if anyone have used it before, but we really, myself and the team, are very proud of using this software and these tools, and it gives us a lot of flexibility, and it has its own algorithm built in, so we don't have to spend time on building up the algorithm. So the case study, when we started to do the case study, we have put certain targets on our radar. Of course, ensure safety of the maintenance team is number one, and maintaining zero accident in our labs and our facility, it's a must. We are putting the second target is improve the uptime of the equipment, increase the mean time between failure, and decrease the mean time to repair. Finally, is to optimize the maintenance cost of the facility and the equipment. We installed the M5 uptime for sensor Edge 1.6 version 1.6 in one of the motor drive end and non-drive end to measure the critical parameter. We power it up using what we call SMBS 24 volt 5 ampere. We connect it to the Wi-Fi network of course, and we use the Skype Spark predictive machine learning artificial intelligence tool software. This is a picture of the tools of the motor, sorry, with installed sensor. And this is a pump side, this is a motor side, and you can see the non-drive end, and the drive end is here, non-drive end is here. And we put four sensors to make sure that we will be able to historize and get as much as information about the performance of the motor. The four sensors continue scanning the critical parameters, total accelerations, axle, temperatures, audio, bearing fault and losses. The data is compressed in millisecond with the motor thermohold set pace
Hello.
in the bearing. Yes.
Yeah, I'm sorry for the interruption, Dr. Khalid. Yeah, the speakers are requesting to move the slides further, like they are having a doubt, like which slide you are representing. Yes, from the slide, like it was from slide 6 only.
Oh, really? Oh my God.
Yes, yeah, we were stuck with the slide 6.
Can you
Please
see? Can,
explain through slide. Yes, yes, you can move further and explain the slides.
can you see?
Yes, yes, now it is visible. You can change time to time. When you explain the second slide,
So,
in the next slide, you can change that slide.
so just as a maybe for the rest of the speaker, maybe full screen is not the right way to do.
Yeah, there is a button at the bottom of your screen. You can click on that. That will make you the full screen.
I did.
Okay, I think it's not working. Okay, no problem. You can move further with the slides.
So shall I go back to which slide you want me to go back to, or
Sixth one. We were
this
all
one?
stuck with sixth one. Yes.
Okay.
Yes. From next slide, you can start your presentation.
Okay. So we're going back to explain the predictive analytics models. The model is a template that allow user to turn past and current data into an actual insight and create positive long-term result. Um, Two different models that we've been focusing on: predictive maintenance model, which forecasts the changes of essential equipment breakdown, and the quality assurance. It's mainly when you are producing an equipment, that spot on and prevent defect and avoid disappointed and extra cost when providing products and services to customers. When it comes to the tools, as I mentioned before, there's so many tools in the market. Some of them are free, some of them are trial free, some of them are subscription prescribed. However, it gives the user deep and real-time insight into an almost endless array of business activity. Tools can be used to protect various type of behavior and patterns. In our study case, we have used the SkyPark software. Some features of the SkyPark software that we have used. It helps us a lot. It has built-in algorithm that we have used. We did not waste time on modifying or building up our own algorithm. And it also have basic KPI tools that can be used during the case study. Moving into the case study in cows, basically our target, we have targets to ourselves, the team, is to ensure the safety of the maintenance team and maintain zero accident in our plant and labs. Second target is to improve the uptime of the equipment, increase the mean time between failure, and of course decrease the mean time to repair. Optimize the maintenance budget was also one of the targets that we wanted to come up with some result on that. Uh, we have installed four sensor H1.6 in one of the motor, drive end and non-drive end to measure the critical parameters. We power up all the sensor using a device SMPS 24 volt. All of them are coming to the same device. Connect to the site Wi-Fi network and use SkyPark software that we have utilized it in full coverage. This is a picture where the four sensor has been installed, two on the pump side and two on the motor side. And you can see here the non-drive end and the drive end is this side, and also the drive end from the motor side is here, non-drive end from this side. The force sensor continues scanning the critical parameters. We have been collecting a lot of information about one of those sensors. The data was compressed in a millisecond with the motor set base information, RPM details, and we have also used the manufacturer information as well as the ISO 10861 standards. Based on the history that we have collected before, the predictive tools forecast the motor performance and the efficiency. We captured the data, the real-time data, and provided understanding of the gathered data. We've done that almost for 4 weeks, 4 to 5 weeks, I would say. Analyze cause and effect with interpretations of the degree of the impact. We have screen and detect abnormality in the equipment and diagnose the root cause of the discrepancy. Finally, we facilitate corrective measure to prevent the unexpected breakdown. Of course, the sensor are having a different set of alarm that it tells us on the control room as well as in the physical location how the sensor is performing. Some of the picture that or the dashboard that is coming from the application that we use, and it give us some real-time information, how many percentage idle, how many was in operation, and how many total alarms that we have received, and the equipment history it's showing since it was up and running. Um, Real-time information, again, different type of parameters that we were focusing on here. And every sensor, it has, this is a non-drive, and we also have a page for the drive in. So all kind of information were monitored and analyzed. Um, we also were focusing on the BMU energy versus the motor vibration sensor drive-in accelerations. And we've seen some result that we have also analyzed. The system finding, the system give us that the vibration spectrum indicate the symptoms of losses, and also give us a different message, losses between structure-based frame and its base. So that was a repeated statement came from the system itself after studying and analyzing all different data. The system also gave us a recommendation of what should the operator and the maintenance should do. Check the entire machine frame of losses and abnormality, and inspect the motor base location belt of any losses, and also check alignment between the motor and the clutches. Basically, those statement was built in the system, but the system itself has managed really to find out what is the real cause between comparing the four sensor data, and come up with at least reduce the finding from 500 finding to 2 finding, and give us an accurate recommendation of what the engineer and the maintenance team and the operator should do. In summary, I would say predictive analytics is become extremely needed in a critical equipment and related industry. Internet of Things and data analytics have increased workflow efficiency and reduced productive errors and save overall maintenance costs. Thank you. Any question?
Thank, thank you, Dr. Khalid, for your presentation. Is anyone having any questions?
Yes, Dilip here. Dr. Khalid, thank you for good information. Is this solution implemented in cloud or on-prem cloud?
Uh, I cannot hear the question.
No, no. Is this solution implemented on-prem or on cloud, Dr.
No,
Khalid?
infrared. Infrared.
Okay.
Yeah, is anyone else having any questions? Okay, no questions, I think, from anyone. Thank you once again, Dr. Khalid, for your presentation. So moving on to our next presenter is from Dr. Aarti Zain from ZP Institute of Information Technology, India, and her topic is telemedicine, present and future aspects of big data analytics. And now I will present the biography of Dr. Aarti Jain. Dr. Aarti Jain is working as assistant professor in JP Institute of Information Technology, Noida, India. She is having academic experience of more than 19 years. She did her undergraduate in mathematics from Delhi University, MCA from Punjab University, MS from BITS Pilani, and PhD from JIIT Noida. She is a member of IEEE, INSTICC, IAENZ, SAFAS, IFERP and TERA. She has more than 20 research papers in peer-reviewed international journals, book chapters, and international conferences. She has supervised MTech thesis and around 100 BTech projects. Currently, she is supervising PhD candidate in the area of social network analysis. She has delivered expert talks in FTPs, KDPs, and workshops. She is special issue guest editor in IGI Global and special sessions organizer international conferences. She serves as International Advisory Committee and a reviewer of peer-reviewed international journals and conferences. She has participated in more than 75 specialized short-term courses. She is a guest editor of upcoming book Lifestyle Sustainability and Management Solution using AI, Big Data Analytics, and Visualization, IGI Global. Her research interest includes natural language processing, machine learning, data science, deep learning, social media analysis, soft computing, big data, and data mining. So, hello, Dr. Aarti Jain. Are you ready with your presentation?
Yes, I am ready with the presentation. Thank you for the
Okay.
introduction.
Okay, thank you. So, I'm going to make you the presenter. Just a minute.
Okay, right now I am with my mobile. If you
Okay.
give me 2 minutes, then I will switch over to my laptop and will be
Yeah.
easy to see.
Okay. Okay. So, we'll be waiting for 2 minutes. Kindly join
Okay,
with your laptop.
okay, fine. Hello, ma'am. It is not allowing me to share the screen. Razina, ma'am.
Yes. Hello.
Uh,
Hello.
not allowing me
Yeah.
to share
I'm
the
going to make
screen.
you the presenter. No, no, just a
Okay.
minute. I'm going to make you the presenter.
बेटे मोबाइल पे चला
Hello. Hello.
Yes, ma'am.
Yes, you are the presenter now. Please share your screen with us.
Are
Yes,
you
we
able?
can able to see your screen. Yes. I think you are using the phone, right?
Yeah, yeah. Actually, some issue with the laptop is coming, so I am using the phone. Are you able to see my
Okay, no
screen?
problem. Yes, yes, it's visible. Can you make it a full screen?
Full screen. Full screen option. Are you able to view it on the full screen now?
Yeah, just a minute. Yeah, hello. Yeah, you can
Yes.
do one thing. Like, can you share your presentation with us so that I can share my screen and you can start
Yes, yes.
explaining from
How
there?
to do that?
It will.
Do I mail you?
Yes, you. Yeah, you can send it to Suzanne Jones. I will take it from her.
Okay, okay. I am sending.
Okay. So we will be waiting for your presentation.
Send to her. I have sent to her.
Okay, just a minute. Give me a 5 minutes. Yeah, hello. Hello, Dr. Aarti.
Hello, ma'am.
Yes, so I will be sharing my screen now.
Okay,
Please just
fine.
let me know. Can you able to see my screen or not?
Okay.
Okay, just a minute. Yeah.
Yeah.
Can you able to see my screen?
Yes, you are
Okay.
opening my PDF. I am able to see it.
Yes, yes. Okay, you can just let me know how to move further.
When I say next, then you will move to the next
Okay.
one. It is PDF.
Yeah, definitely.
Okay, fine.
Yes.
So, should I
Okay.
start?
Yes, yes, you can start.
Do I need to on the camera?
No, no, no need. It's up to you. Like if you
Okay,
want, you
fine.
can on your camera,
I'm okay
otherwise
with
no.
I'm okay with the camera also, no problem.
Okay.
So let's begin with my topic of the talk is telemedicine, present and future aspects of the big data analytics. Next, next please. First, we must know back, ma'am. Here the option of sharing is coming to me. Do I try to share, ma'am?
Yes, yes, you can do. Like I think it will not work.
Let me
So you can
try.
let me know. I will move forward.
Okay, fine. Okay. So let's begin with first let us try to understand what the telemedicine is. It is the delivery of the healthcare services from the distance. Distance means from the remote area locations. We want to deliver the healthcare services among the people. To understand it, we must know who delivers the healthcare services, whom it is being delivered to, where it is actually being delivered, and when it is being delivered to. If we answer these type of the questions related to the delivery of the healthcare services, we will be able to understand what the telemedicine is. So let's move to the answers of who, whom, where, and when answers. Next, please. The delivery of the healthcare services is being done by the healthcare professionals, whether they are the doctors, they are the nurses, they are the healthcare staff, paramedical staff, any kind of the people who are assisting you with the medical services are the healthcare professionals. It is these kind of the services are delivered to me, to you, to our family members, to our community health. And whenever we feel the problems like the distance issue is there, remote areas are there, even in the villages, we can go for the telemedicine. It is responsible for the not only for the diagnosis but also for the treatment, prevention of the diseases as well as for the injuries. And in the nearby future, it is responsible for the telesurgeries also that I am going to cover up soon. Next, please. Now we know that who are the people to whom, where, and when these telemedicine services are being delivered. Now the question is how we are going to integrate all this stuff, how to sign everyone, how to club them together. To answer this question, we move further. Next, please. Telemedicine amalgamates various things like communication technology, information technology, medical services, biomedical engineering. It is done with the help of the communication technology like your laptop is there, tablets are there, your desktops are there, your cell phones are there to connect with the help of the Wi-Fi networks, mobile hotspots. You can have the information technology through the servers, through the internet, through your social media, everywhere. It is accompanying huge data into the picture. Medical softwares, they include variety of the research, variety of the evaluations. Even as in the example you are seeing that artificial legs are being provided, even wearable computing are there. So telemedicine accompanies integration of all this stuff. Next, please. Once we understand what the telemedicine is, the next question which comes to our mind is what are the benefits of telemedicine? The benefits of telemedicine are in terms of the cost effectiveness, better access, convenience, millennial demand, reduced absenteeism. Let us try to understand these benefits one by one. Next, please. Cost effectiveness. When we go to the doctor in a physical mode and when we go via the telemedicine, let us see is there any cost effectiveness or not involved over there. Like in terms of the staff, we need full-time staff when we have the one-to-one outreach. However, when we go by the telemedicine, there is one or two coordinators for few weeks, which is costing to a much reduced amount. Transport facility in case of the telemedicine is null because we are working even by the home also. Equipment, we can work even with the second hand laptop, even mobile phones, which is costing much lesser as compared to the other equipments in the online mode. Administrative staff, administrative purposes, even with the help of the SMS messages, email messages, video conferences, it can be done. So overall, the total cost, it is quite reduced in comparison to what we do in the physical mode. Next, please. Better access, definitely telemedicine is useful for everyone. It is reaching everywhere to every person. It is giving you the better access to the healthcare, and it is giving better outcomes in terms of the human care, human health care. Next, please. We have advantage of the reduced absenteeism. For example, my aged father or mother, he wants to have the regular checkup with the doctor but is unable to move out of the bed, but wants to have the regular checkup. What to do in that case in the physical mode? So telemedicine is a good solution in that case. With the help of the video conferencing, with the help of the real-time message, we can get the investigation from the doctor, as in the picture also. Next, please. Convenience. Even child can get its benefit. Even the feeding mothers can get its benefit. Everyone can get the benefit out of the telemedicine. Next, please. Millennial demand is another important aspect of the telemedicine. What actually is the millennials? They are characterized by the optimistic, self-directed, healthy lifestyle oriented people, but they have certain problems with them, like they may be stressed because of their living style, maybe they suffer from the depression, they may suffer from some kind of the anorexia, so they may suffer from the anxiety, obesity. So telemedicine is a good solution to them. And when the market survey is conducted, it is found that around 28% and more, they don't even bother to visit their family doctors, and even 40% they have the relationships with the doctors, but they don't want to interact because of the cost value associated in the physical mode. So telemedicine for such people is a good solution. Next, please. After understanding the benefits of the telemedicine, we must understand the diagnostic tools for the telemedicine monitoring. There are the several tools associated for it, like temperature sensors are there. Some of you are using it at home also. Omron thermometer, it is quite common these days. Blood pressure monitors, it is tied not only to the your hand, it can be tied to your finger, even to the wrist. Pulse pressure monitor tied around your waist. Electronic stethoscope is there. ECG based heart rate systems are there. Exercise speedometers are there. How many walks, how many steps we have taken, how many calories are burned. So all this stuff can be known from these tools. Next, please. Even electronic weight or body fat scales are there. You have pulse oximetry, which is quite common during your COVID period. Even for the diseases like asthma and diabetes, we have the solutions over there. We have as a manual recorder, we may find no interest in recording the manual diary, but we have the devices which are having the micro diary card associated with it, as shown in the figure also for the asthma breathing monitors. Even for the sugar patients, we have the solutions. We have the regular monitoring of the sugar level, glucose meters are there. So likewise, number of the ample tools are available for the telemedicine monitoring. Next, please. After understanding the variety of the tools, we must understand how the patients and the doctor collaborate with each other. The data is being captured by these electronic devices like electronic stethoscope, ECG machine, digitizer, pathology equipment, ophthalmology instruments, your ENT equipment, imaging devices, dermatology camera. So all the images, pictures, videos, information is being captured at the nodal center, at our houses, at our premises, and these are being delivered to the practitioners with the help of the referral centers, where internet facility is there, a video conferencing facility is there, real-time facility is there, even store and forward facility is also there. So telemedicine will help you in collaborating between the nodal center, that is your patient center, referral center, that is your doctor center. Next, please. So we must understand what types of the telemedicine are. There are the three main categories. First is the store and forward. Second is the interactive services. Third is the remote monitoring. Let us understand the differences among them, what these categories are, and what are the difference among these three categories one by one. Next, please. Store and forward. In this store and forward type of the service, the first important thing is that it does not require the presence of the doctor and the patient at the same time to be available online. So it is mainly being useful for the non-emergency kind of the services like the teleradiography, teledermatology kind of the stuff. We have the medical data, we have the medical images, we have the bio signals, and those data are collected from the patient and are transmitted to the doctor. Intermediate, we have the primary case practitioners who collect this information from the patient and deliver it to the remote specialist at and then later on the remote specialist diagnose it, understand it, and send back his investigation and consultation to the patient. Next, please. Video conferencing or interactive services mode. Video conferencing is there, real time solutions are there. Most of us these days are using this kind of a facility where patients choose a convenient time according to the availability of the doctors, and this is done with the help of the telemedicine software, which actually provides the virtual meeting rooms among the patient party and the doctor party. So two parties have the videos interaction with each other, and they chat with each other, they discuss the issues, they try to find out the solution, diagnose, treatment, everything is being done online. So practitioners, they give their real-time video consultation, they diagnose them and prescribe the e-consultation medication services all online. So video conferencing mode is there with the help of the real-time scenario. Next, please. Third one is the RPM, that is remote patient monitoring services, where what it does is patients, they regularly use to self-measure the vital signs, or they may use a wearable technology like wearable wrist watches are there for their automatic measurements. They just have to tie up and it is being calculated like your what you say, your BP rate is calculated, your calories burned is calculated. So RPM devices are there which are responsible for measuring, recording and transmitting the data from the patients to the practitioners. Then practitioners, they assess the measurements, they get the data from the multiple wearable devices, and they get the assess the measurements, they provide their feedback and adjust care plans accordingly. So this is mainly being done for the remote consultation, even for the remote education, remote counseling type of the stuff. RPMing is widely being used into the picture. Next, please. Now we come to the number of the applications for the telemedicine. We have telemedicine applications varying from emergency healthcare to the video consultancy to the telecardiology, then telepathology, teledermatology, telepathology, teleophthalm- op- sorry, teleophthalmology, teleoncology, telepsychiatry, teledentistry. And although if we remove the word tele out of it, so you are aware of what the cardiology is, what the pathology refers to, what your ophthalmology is, oncology, psychiatry, dentistry, even telesurgery is also going on these days. So, but what we have done for the remote distances, we have added tele. So tele means distances, remote location based. So let us try to cover and understand them one by one. First is the emergency healthcare. Next, please. In the case of the emergency healthcare, uh, in the telemedicine system, the doctor don't have to jump or move from hospital to you. Using the emergency telemedicine, it allows your emergency physician to stay where he or she is and where he or she is needed most, rather than wasting or spending the time traveling back and forth between the hospitals and the independent your emergency department group. So it is available to you online. Next, please. Video consultation. It is quite easy. It is available to you just a click away. Through this online consultation session, you can speak, you can do the video call with your specialist, and you use the smart devices. You have the smartphones, tablets. Even these days, computers are, TVs are smart enough where you can do the video consultation at the comfort of your home. Your one kid is playing beneath you, and you are waiting for the arrival of the second one at the comfort of that place, so you can do the video consultation. Robust information technology, healthcare delivery systems, they will uh, enable you the seamless online consultations and e-prescription. Next, please. Telecardiology. It is related to the diagnosis and treatment of disorders related to your heart, your congenital heart defects, your coronary defects, artery diseases, heart failure, remote clinical using technology like video conferencing, real-time solutions are there which help you to sort out your heart-related issues. Next, please. Telepathology. Uh, it is nothing but the practice of the pathology at a distance. So what it is done is it is helping you to, it is providing you the facility to transfer the image-rich pathology data between the distance locations for the purpose of the diagnosis, for the purpose of the education, for the purpose of the research. Here, pathologist, he is able to select the video images for the purpose of analyzing, rendering of the diagnosis, evaluating them. Here we can use a television microscopy where the forerunner of the telepathology, they did not require that a pathology have a physical contact or virtual hands-on involvement during the selection of the microscopic fields of view for the purpose of the diagnosis and analysis of the pathogens. As you are seeing in the picture, through the visual mode, it is able to diagnose the root cause of the problem. Next, please. Teledermatology. Again, telecommunication technologies, they are used to exchange the medical information like your skin conditions, your tumors related to your skin, rashes on the skin. So over the distance call, over the video, audio, visual data communication, it is being performed. Applications, they comprise of the healthcare management, again related to the diagnosis of the skincare problems, consultations related to the skincare, treatment and solutions related to that, as well as the continuous education and monitoring to the patients. Next, please. Teleophthalmology. It is nothing but the branch of the telemedicine that delivers you the eye care through the digital medical equipment, through the telecommunication technology. Your application of the teleophthalmology encompasses your access to the eye specialist. Uh, Even when you are far away from the specialist, you are able to get the proper care for your eyes. Your patients get the remote access. You are being taken care for the ophthalmic disease screening. You can diagnose, monitor, as well as distance learning related to your ophthalmic issues can be performed. Next, please. Tele-oncology, again one more application of the telemedicine. It is the application of the telemedicine to oncology, which includes three main stuff, that is the diagnostics, treatment, and supportive care. Under the diagnostics, we have the lab reports, we have the lab solutions, lab recording, radiology, then pathology. Under the treatment, we have the surgery, radiation oncology, medical oncology is being provided, and supportive care for the rehabilitation as well as for the palliative tasks, where uh, pills taking, your daily medication are being taken care of. Next, please. Telepsychiatry. It includes your psychiatric evaluations, mental health care consultation, therapies. In the therapies for the telepsychiatry, it doesn't only include the individual therapy, it includes your family counseling also, because the patients who are suffering from the psychiatric diseases, their family care is also important. Then group therapy is there, patient education is there, medication management is being provided. It can also involve recording the medical information via your images, videos, and sending this to the distant site for a later review. For example, I give you my own example. I have a nearby cousin who is a psychiatric patient. Before the pandemic, we used to take him to the psychiatrist. He is a senior psychiatrist, Dr. Sanjay Patnaik, in the Women's Hospital, Lajpat Nagar, New Delhi, India. So every time we have to take the offline consultation to him, and we have to carry the patient along with us, and sometimes patient is not willing to go over there, which was also a big challenging task. But with the help of the telepsychiatry, since the pandemic, we have not visited the doctor in the physical mode. We are taking the teleconsultation, and doctor is seeing, diagnosing, giving the consultation, as well as counseling to the family members related to my cousin. So that is a big advantage to the telemedicine. And this is a real example which we people are showing in our own family. Next, please. Teledentistry is another example which creates opportunities by allowing all the players in the dental care matrix to communicate and collaborate remotely across every step of the patient's dental health journey, where starting from the pain in the teeth to the major problem being rooted, like your root canal and other stuff are being taken care. It includes again your information technology, telecommunications for the dental care, consultation, education, assigning of the braces in your mouth, and other such related stuff. Slides have gone, ma'am. Razina ma'am, slides are not visible to me.
Hello. Yes, it's the slide is visible.
Can you go back a little bit?
Yes. Is it
So
okay?
dental care, consultation, education, and public. Yes, yes, fine. Dental care, consultation, education, and public awareness is important in case of the teledentistry. Next, please. Telemedicine is incomplete without discussing the coronavirus COVID-19.
This conference will now be recorded.
Hello, Dr. Aarti Jain.
Yeah, ma'am, I am able to hear you.
Yeah. Yes, I'm very sorry for the disturbance. I think there's a network issue.
Yeah, yeah.
Yeah, so I will share my screen once again.
Okay, fine.
Okay. Okay, so can you able to see my screen?
Not yet. Yes, yes, I am able to see your screen. Now you are opening my
Okay.
PPT.
Yes. Please let me know on which slide
Uh,
I was.
Move ahead.
Yeah, is it this?
Move ahead.
Okay. Yeah, I think this one.
Yeah, I am here. So everybody able to see the screen? You can check, ma'am.
Yes, yes. I think it is visible to everyone. Hello?
Yes.
Okay.
Uh,
Yeah, please continue.
okay. So we were talking about the coronavirus COVID-19 related to the telemedicine. Uh, so let's have a brief look into that aspect also. Next, please. According to the survey, it is observed by the Chiang et al. And his colleagues that 57.5% of the people they have used the telemedicine for problems like the headache disorder, especially the pandemic. And later on, 62.1% of they have observed that they have rated that their experience using the telemedicine as a quite good. And 44.8% of the people they have said that they will continue using the telemedicine even once that your coronavirus is not there. And
Yeah, hello, Dr. Arti.
yes,
I'm sorry for interruption. There is a disturbance from your side. I think your voice is not audible properly.
okay.
Yeah, can you
Somebody's
please
mic is
wait for
open.
1 minute? Yes, can you
Okay,
please
fine.
wait
I
for
can wait.
1 minute?
I can
I will
wait.
check.
Treba bi sutra ići na mali geo.
Hello.
Yeah, hello, Dr. Arti.
Yeah.
Yeah, am I
Hello.
audible to everyone?
Yes, we are able to hear you.
Yes.
Yeah, I request all the speakers and all the attendees to make mute yourself as it causes disturbance to the speaker who is presenting in the webinar. So, hello, Dr. Aarti. So, it's the presentation is open. You can start presenting.
Hello, am I audible to you?
Yes, yes.
Yes. Okay. We were discussing the survey from the Chiang and colleagues, and it is observed that 57.5 they have opted for the telemedicine during the pandemic for the problems like the headache disorder. Then 62.1% they have rated their experience that the telemedicine is quite good to them, and 44.8% they said that they will continue using the telemedicine for the headache and other related problems. And during the pandemic, it is observed that the kind of the telemedicine technology which is being used from the decreasing order, it is with the help of the video or the webcam, 37.8% to the image sharing technology, uh, sorry, 57.8%, then image sharing technology, 55.5%, emails, then patient portals are there, video conferencing via groups are there, remote patient monitoring and other such stuff is there, ranking in the decreasing order. Next, please. There is a one excellent paper on the telemedicine, that is variation in the telemedicine. Uh, Screen is too small for me to read.
Yeah, hello.
Hello.
Yes. Uh, is there any problem, doctor?
Yeah. There is a one excellent paper that is variation in telemedicine use and outpatient uh, care during the COVID-19 pandemic in the United States. It is published in Health Affairs. 2021 paper is there, where telemedicine visits by the clinical specialties are mentioned. Endocrinology is given the maximum rating 67.1%, followed by the gastro, followed by your neurology, then up to the chiropractor. Then, according to the people ranking is also there, demographic characteristics based telemedicine visits by the patient is also mentioned. Then their percentage change in terms of the weekly visits in comparison to the physical mode from pre to the during pandemic period is also being taken care in this paper. So those who are the researchers in this field, they can go through this stuff and find this paper in detail. Next, please. Another survey is conducted where it is asked how likely you are to make a telemedicine appointment after the COVID-19 pandemic is over. Then it is found that 83% of the patients are likely to use the telemedicine even after the COVID-19. And more people are using it on the regular basis these days. They have started using, like my parents, they are never been familiar to the mobiles, laptops. Now they are also getting used to uh, build them into these technologies, and definitely this percentage of 83% is going to reach to the 93% also in near future. Next, please. So we come to the future of the telemedicine. Next, please. The future of the telemedicine is defined in terms of the key market highlights, which are in terms of the market growth, market driver and market trend. What the market growth is, it says the global telemedicine market is expected to grow from a CAGR annual growth rate of over 19% from 2018 to 2022. Further enhancement up to the 2025 and 2027 mark is also there in the next slide. Next, please. So global telemedicine market, it is forecasting to grow up to the 21.1% from 2021 to the 2025 in terms of the US dollars. Next, please. If we talk in terms of the continents and the countries, so we have a steep increase in the usage of the telemedicine from 49.8 billion to 266.8 billion up to the forecasting of 2027 in terms of the North America, Europe, Asia Pacific, South America, Middle East and Asia zones. Next, please. Then we talk about the market drivers. Uh, I talk in terms of the India telemedicine landscape as well as according to the US medicine landscape. When we talk about the India medicine landscape, we have the core medicines, that is business to consumers. We have the add-ons in the telemedicines. We have telemedicine technology providers in terms of the business to business solutions, and omni-channel telemedicine solutions are also there. Some examples into it are like Procto is there, then your Call Health is there, your add-ons are like MedLife is there. Further solutions are being provided like by the Apollo Pharmacy, Amrita, Fortis Escorts, and number of the other such scenarios. Next, please. The US telemedicine health landscape, it comprises of various companies. American Well is there, then Philips is there, your uh, Apple solutions are being provided, Great Call is there, Honeywell solutions are there. So market is booming. Market is further booming and it is rising at a very high rate or rocket high rate, you can say. Next, please. Then comes the market trend, growing the acceptance of the video consulting. Market trends are increasing. In the 2019, we had seen a different market trend, which is moving towards the issues of the insurance companies. Like right now, insurance companies, they are sustainable for the LIC kind of the policies which are in the physical mode. But yes, trends are changing. Insurance companies are working with the telemedicine also. Government plans are launching these days, like Kilkari is there, your Sanjeevani Health is there in the India. There are the number of mother-child healthcare is there. So government is providing the support for the adaptation of the telemedicine services, and demand for the psychological mental health consultation apps. They are actually fueling the market growth. Next, please. Sometimes people ask, is the telemedicine same as telehealth, or is there some difference between the telemedicine, telehealth, or e-health? What are these? So, at the broader level, what we categorize is telehealth. It has a subset of the telemedicine, it has a subset of telehealth care, and the e-health. And they are interrelated like telemedicine. In during the application scenario, we have discussed teleradiology, telepathology, teledermatology, psychiatry, and so on. We have discussed already. Under the telehealth care, we have the telehome care, telenursing, telecoaching, even telerehabilitation facilities are also booming up. So we have the amalgamation of all the technologies from the big data, because what is happening actually, the images, videos, photos, video conferencing, your sensors data, all what is that? All are providing the huge bulky data, which is not being fed in just simple Excel files. They are in the form of the unstructured data, and those data are being captured. They are being captured from the patients. They are being diagnosed by the practitioners. Intermediate practitioners are there, or the prime practitioners are there. They transfer it to the specialist. Consultation is being provided in the remote areas also from those specialists, and your sufferings, your problems, your injuries, your diseases are trying to be eradicated out with the solution of the telemedicine. Next, please. For the budding researchers, we have the telemedicine conferences which are upcoming not only in 2021, 2022, 2023, and so on. A link I am sharing over here. Those who are interested, they can go to this link. Even in the September 28th onwards, in the United Kingdom, telemedicine workshops related to the digital healthcare uh, workshop conference is there. Then in the May, June, next please. Then in the July, August, September 2022, even in the October, November, December 22, you are finding that various countries all across the globe, whether it is Canada, whether it is France, Dubai, you name the country, they are going to discuss the telemedicine and related stuff in the upcoming conferences. You can share your research work, you can promote your ideas over there, and get updated with the latest further advancement with the help of these telemedicine conferences. Next, please. So I have told you in the even beyond the December 2022, we have the records. Next, please. Even in the 2023 January, there are the conference in the Japan, then in the Singapore is there, Switzerland is there, Spain is there, Saudi Arabia is there, which was not so budding in the past few years. If you see, these are all the futuristic conferences which are upcoming up to the 2023. I have marked the records for your sake. Next, please. So I have made a record till August 2023. For more, you can search further and find out according to your suitability. Even in the United States, Italy, then Denmark, there are the number of the upcoming researches being conducted by the conferences. Next, please. So at the end, what I can say is the doctor will see you now via the telemedicine. It is quite a step better for the patient care, not only for the individual patient, for the family care, for the group care, for the community care. Thanks. Next, please. Thanks. That's all from my side. I am open for questions. You can ask. Ma'am, you can show my signature for those who can communicate with me later on. That is the last screen.
Hello, are you getting my voice, Arti?
Yes. Hello, Mukul sir.
Okay. Hi, hi. So basically, this is a generic presentation about the telemedicine, which help us to understand the how it's work, the telemedicine, and overall fundamental knowledge about the
Yes.
telemedicine. I'm just asking about the what kind of infrastructure will be the architecture, like how can gather your data, how can you ingest your data in the platform side. Do you have the any kind of information?
Yes.
How can we build up?
Yes.
Yeah.
Uh, partially, I have. I will not say that I have full knowledge related to that, but yes, I will share whatever knowledge I have. Like the Apollo software solutions, they are already bulging out in the Indian scenario, where they are providing the, a small, you can say a corner kind of the facility where even a remote person can go there, sit there, and discuss his issue. And uh, prime practitioner is there who will record his voice, who will send his information, what kind of the trouble he has. He has
Yeah.
some stomach problem is there, or headache problem is there, or fever kind of
Okay,
problem is there,
no, I'm
and will transfer.
yeah. Sorry for interrupt. Basically, this is a simple kind of. I think it's a process side. I'm just asking about
Yeah.
the your backend side, like in a software side, because I am thinking this is the overall webinar based on the big database technology. Like I'm just giving the some example. If we are capturing all kind of binary and the text data, so
Hmm.
first we need to ingest into the big data platform. So what kind
Yeah.
of technology we are using to ingest all kind of data, where we can store, like you have the on premises infrastructure or the over the cloud. After that, we need to process all kind of binary and the semi structure and the structure kind of data. So which kind of algorithm we are using, and which kind of analysis we are storing into the different kind of NoSQL or the another kind of database or the time series
Yes,
database.
yes,
So I'm
no
asking
sequel.
about, yeah,
Yes, no
yeah, I'm
sequel will be
asking
there,
asking
but advancement to the NoSQL. NoSQL is like you can say is far behind now. There are the other graph-based algorithms will be there where your key versus key versus value pair combination is there. That kind of the algorithms are there at the back
yeah,
end. Then
yeah, I'm asking about this kind of information
yeah,
because
yeah,
I
yeah.
think
Actually,
yeah, this is the architect. Yeah,
actually, I have that information in another slide. If you want to go to that architecture type of thing, I have
yeah,
another
you can
slide
share
with
with
me.
me. Yeah, you can
I
share
will.
with me so I can.
You okay? You can ping me. You can mail me. I will share those slides with you because you want completely an architecture
Okay,
type of the scenario. What I am getting is, so I have that information
okay, okay.
separately
So
available in the another slide. I will share
okay,
with you.
to can to can okay, can you ping your email ID over the chat? So I
Uh,
will, yeah, definitely reach
Razina,
out to you.
can you share my signatures at the last slide so that
Yes,
audience will
yes.
get acquaintance with that?
Yes, yes. I'm going to
You
share
can
now.
ping me with my LinkedIn. You can ping me via my email IDs or my WhatsApp
Yeah,
number. Everything is available.
Yes, I'm
okay,
going to
okay.
share
Thanks,
in the
Arti.
chat box.
Actually, what I assume is you want a core architecture into it. Actually, I have not
Yeah,
covered the
yeah,
core. Actually,
yeah.
I have not
This is the
covered the
process
core
side.
architecture because
Yeah,
it came to me that people are novice towards the telemedicine. So start from the beginning only. So I have left that part. So I will definitely be sharing with you. Okay,
yeah.
I have the
Yes.
separate
This may
title.
be the, yeah. This may be the miscommunication. So I think I am
Right.
thinking this is the based on the big data and the newly adopted technology.
Uh-huh.
Okay, thanks, Arti.
I will
Yeah,
share with you. I will share with you.
yeah.
Yeah, I
Any
shared
other
the
question?
details of Dr. Arti in the chat box. Can you see
Any
Dr.
other
Arti?
question? Mm, it is not visible to me. You can share my last slide. Everything is visible there.
Okay, then I will share my screen once again.
Okay. Any other question, audience?
Yeah.
Hey,
Is
to
it
add, can
visible?
you hear my voice?
Some echo is coming. Is somebody speaking?
Hello, can you hear me? This is
Yes,
Yeah,
you
me.
yeah.
can. Yes.
Okay.
Narasimha sir, hello. You are
Okay.
audible.
So, Aarti, to add to your this thing, to the question what somebody asked, so
Mhm.
that in the industry, what we do is we capture the video as well as the audio and the discussion between the patient and the doctor, and we store that data and
Mhm.
put it into ingest the data into big data platform.
Mhm.
Okay, depending on the system in the sense, individual source companies have their priorities. So for me, if I am an insurance agency, how that insurance is coming up and those type of things as a separate thing. But how the data is being ingested means you can use Kafka and those type of things. That internal system architects, the company architects will decide how the ingestion pattern will be and how the transformation process, how the what is the rules that needs to be ingested during the ingestion process, those type of things. So to me that is a broader discussion, and whatever is the information you are looking out might be a specific scenario you can share with, but I don't know, but what I am looking at it is a.
Sir, you are absolutely right. What you want actually is now I am getting from you people is you want to discuss how actually the Kafka is working at the background, how the Flume is working, how the Hadoop technologies is working. So you have the expectations like that. So I have all the information. I have a separate PPT. I will share that information with you people.
Okay, that would be great.
Huh. So we have even in the Hadoop we have the zookeeper. Even in the Hadoop we have your wildcard of the scenarios are there. Management tools are there. Monitoring tools are there. You want to dig into that? I will share that information with you.
Okay, cool.
Okay. Any other question?
Okay, anyone else having any questions? Okay, no questions, I think. So I'm sharing Dr. Aarti Jain's details. So if you have any further questions, you can contact her through her email ID and phone number. And even I copied the content in the chat box as well. So I'm now closing my screen so that we can move forward.
Okay, ma'am. Thank you.
Okay, thank you. Thank you once again for your presence and presentation.
Thank you.
Okay, so moving on to our next plenary sessions, headed by our session chair, Dr. Dilip Musa, Infosys, USA. So before that, I will give a brief description about Dr. Dilip Musa. Dilip Musa did a double master's with computer science and MBA. He has 21 plus years of professional experience in the area of enterprise data and analytics and SME in data architecture, data engineering, data governance, cloud strategy, IT outsourcing, global delivery, retail banking, manufacturing, and telecom. He has living and working experience in USA, Australia, UK, Italy, France. In addition to this, he has experience in serving as a board member for startups in manufacturing and advanced materials. So our next presenter is Dr. Priyak Bandyopadhyay he is a senior data scientist from Singapore. Hello, Dr. Priyak. Are you ready with your presentation? Hello? Hello, Dr. Priyak. Are you with us? Yes. Actually, your voice is not audible to us. Am I audible to everyone?
Yeah, hello Rosina. Yeah, you are audible. I don't think we are
Yes.
able to hear Priya.
Yeah. Hello, Dr. Priyak. He is in the session, but I think he's not active. So if you allow me a few minutes, I will be contacting Dr. Priyak to be active. Yeah, hello. I just contacted Dr. Priyak. He is having some technical issue, so he will be joining with us right now in 2 minutes. I'm sorry for this delay. I think Dr. Priyak has left the session. I will contact him just.
Hello? Hello? Can you hear me?
Hello?
Regina? Regina, in the interest of
Yes,
time, can we move with the second participant, next participant, and in
yes, yes.
between you can talk
Okay
to.
then.
Yeah.
Okay, okay. Okay, Dr. Dilip, I will be announcing the second presenter, that is Dr. Hamida Ibrahim from University Putra, Malaysia. And her topic is Skyline Query Processing over Uncertain Data. Hello, Dr. Hamida.
Hello, can you hear my
Yeah.
voice?
Yes,
Okay,
it is
thank you.
audible.
Okay,
I think
thank
Dr.
you.
Priyak is having some technical issue, so I would
Yeah,
request you to present your talk right now. Are you ready with your
okay.
presentation?
Yes.
Okay, so I'm going to make you
But
the
I
presenter.
can't. Okay,
Just a minute.
okay.
Um, yeah, hello. Can I know
Yeah,
through which name? Okay, I just got University Malaysia.
Mr. Putra, Malaysia.
Yes. Now you can share your screen with us.
What do we call this background? Okay. Share.
Yes, perfect. Your screen is visible to us.
Yeah, yes. Hang on. I'm looking for the. There's so many things on the desktop. Ah,
Okay, okay.
this is. I'm so sorry. I think I put it somewhere. Where is it? Yeah, suddenly it's missing. Hang on, eh?
Okay,
So
okay. You
sorry.
can take your time. There's no problem.
Yeah, so sorry. Okay. Okay, can you see my slide?
No, we can able to see your screen, but the presentation is not visible to us.
It's not visible to you.
Yes, we can see the wallpaper of your screen.
Oh, let me try again.
Okay.
Okay, share your screen. Share. Now I'm opening the PowerPoint presentation. Can you see it?
No, the presentation is not visible.
Oh, why? What should I
Only we
do?
can see your like your
Yeah, I
screensaver
know. You can
only.
see all these documents on the screen.
No, the
There is a
documents
power.
are also not visible.
Oh, I see.
Yes, only the blank
Let me,
screen is visible.
only blank screen.
Yes. Or else you can do one
Okay,
thing. Please once
hang
log
on.
out and again you log in. I will make you the presenter. If it asks for the pop-up, you can allow to share your full screen. There will be two options. One is to share your presentation, one is to share your full screen. Please select full screen.
Okay, let me try this one.
Okay.
Now, can you see it?
No.
Can you see it?
No, only screen and the cursor is visible to us.
Oh dear. So what should I do? I'm so sorry.
So please once log out.
Log out from the system and then?
Yeah, log out from the session and again rejoin the session. I will make you the presenter once again. Then
Okay.
you can share your screen with us.
Okay. So I leave the session, okay?
Yes, you can leave the session.
So
Yeah, hello, Dr. Hamida.
okay, what should I do?
Yes, I'm making you the presenter.
Okay.
Yes, you are the presenter now. Click on the screen button.
Okay.
Yeah, allow to share your full screen.
So under system preferences, is it?
Yes, you need to give permissions to share your screen with us.
Yes. Can you see my screen now?
No, only the screen. Okay, you can do one thing, doctor. You can send your presentation to Suzanne Jones. I will share my screen and you can explain from that.
One second.
Okay.
Can you hear
Susan
me?
Jones.
Hey, are you using two screens?
Sorry?
Are you using multiple
No,
screens?
only one.
Okay. What are you sharing?
Hang on. I'm sending the PowerPoint presentation to Susan right now.
Yeah,
Okay.
okay.
Okay. Already
Okay then.
sent through emails. So
Yes, you can
Susan,
send through
hopefully,
email and if it's a
yes.
big file, you can share through WeTransfer.
Already
Once you
submitted.
send to her, yes, once you
Oh, yeah,
send to
already
her, please
submitted
let
to
me
her.
know. I will take it from her.
Already submitted to her.
Okay, then. Okay, allow me a 2 minutes. I will take it from the Suzanne and share it in my screen.
So sorry about the technical problem.
Okay, there's no problem as this online webinar. Sometimes problem happens. Yeah, hello, doctor. Now your screen is visible to us.
It's now visible to you.
Yes, now we
Okay.
can see your Gmail.
Okay.
Yeah, perfect. You can start your
Okay.
presentation,
Sorry for
making
the
it a full
technical
screen.
problem. Okay, thank you very much. Let me introduce myself. I'm Hamida Ibrahim. I'm from University Putra, Malaysia. I'm very delighted to share our research work. These are my team of researchers, Associate Professor Dr. Ali Amir Alvan from Ramapo College of New Jersey. So sorry about that. And Dr. Nurul Husna Muhammad Saad from Siaga Informatics Malaysia, Dr. Ma'ruf Muhammad Lawal from Ahmadu Bello University, Nigeria. So what I'm going to share is the research works that we have conducted with regards to Scala and query processing over uncertain data. So the outline of my talk will be based on these three main points: multi-criteria decision making, and then we're going to go through preference evaluation technique, and then Scala and query processing, and how we can process Scala and queries when we have incomplete data, imprecise data. If I have the time, then I'll proceed to other type of nature of data. Okay, let us discuss about or have a look at what is actually multi-criteria decision making. So based on Wikipedia and other sources as well, more or less, they give the same definitions: multi-criteria decision making, or in short, MCDM, or multiple criteria decision analysis, MCDA, is a sub-discipline of operations research that explicitly evaluates multiple conflicting criteria in decision making. So that means we want to make decision and we have to analyze several criteria, both in daily life and in settings such as business, government, and medicine. Okay, and then we also have what we call conflicting criteria. These are normal or typical in evaluating options. Okay, example, very simple examples. I'm sure everyone has actually experienced this: making decision when you want to buy a house. There are many criteria. There are many criteria that need to be considered. We have cost, for example, or the price of the house, location, proximity of schools, public transportation, or facilities, and so on. Even if you want to buy a car, well, decision has to be made based on certain criteria. Okay, maybe the price, safety, interior comfort, MPG, and so on. Even choosing a hotel for holiday, for example, okay, there are many criteria need to be considered before we decide on a particular hotel. But the challenges, what are the challenges in making decision? Of course, there are too many criteria. Okay, in database, the criteria are also called or known as attributes or dimensions. So there are many attributes, there's many dimensions to be considered. Some criteria, we notice that they conflict between each other. Okay, for example, price of a hotel, the rate of a hotel versus the distance from the beach, for example. Too many objects to analyze. Okay, objects over here can be, for example, hotel, it can be car, it can be anything, objects that we want to choose actually. So there are too many objects to analyze, and the volumes of data might be, like big data. Users with different preferences, well, we notice that when we want to evaluate the query or the request, we
Hello.
notice that users will have different preferences. Okay, what they like, of course, will be different. Imperfection in objects, the objects that we analyze, not necessarily they are perfect here. What we have, what we call data uncertainty, which is the degree to which the data is inaccurate. Imprecise means the value during the process is not known. Is not exact value. Untrusted and unknown. Unknown means we do not know the value during the processing of the request. Okay, there are several techniques that have been proposed with regards to, sorry, I'm going to go back, with regards to multi-criteria decision making. One of the popular techniques is what we call the preference evaluation techniques. This one, preference evaluation techniques. Okay, preference evaluation techniques comes from the preference queries. If you look at this diagram, figure 1 over here, I'm going to use this, okay, figure 1. So under query processing in database system, we can actually categorize this query processing into two. We have traditional queries and then we have preference queries. Under preference queries, researchers have come up with so many ideas, so many different ways of processing the queries. And then what we have over here, for example, top K queries, scaling queries, and so on. There's so many actually different types of queries under preference queries. Okay, let me give you some brief idea about this preference evaluation technique. There are many, so I'm going to only go through some of them so that you get a better picture about how objects are being filtered. Okay, so the first technique is called top K technique. So top K technique sorts the objects of a data set by aggregating the values of each individual attribute or dimension of an object as a single value involving a monotonic ranking function f. So in other words, to use this technique, we need to know the function that we have to apply to the objects. Okay, the best K, because the name is top K, so we are looking for the best K objects from the collection of objects that we have. So the best K objects are sorted according to the best scoring value based on the function f. So for example, now if you have two objects called or labeled as PI and PJ, okay, these two objects come from the same collection, the D data set, and preference ranking function f. Okay, PI, we see that PI is better or dominates PJ, but of course when we see PI dominates PJ, we need to actually inform the system whether we are looking for greater value or lower value. Yeah, which one is better? So for example, if greater value is better, so we can see that PI dominates PJ. This is the symbol for domination. Okay, PI dominates PJ if and only if the value of this function of PI is greater than the value of the function that we applies to PJ. Now, if you look at this example over here, this is just a toy example where we have 7 objects. Okay, you can imagine that they are hotels, for example, maybe cars, or any other objects. Okay, we have 7 objects. Now, we would like to get the two best objects. Using top K, what we need to know, we need to have a function. A simple function would be, for example, like the sum of the values of these 3 dimensions. Now, D1, D2, D3, you can imagine they are the criteria that we need to consider before we make the decision. So if our function, for example, our f is equal to d1 plus d2 plus d3, and we're looking for the 2 best objects. So what we need to do is just to total up these values of these dimensions. For example, T1, the value is 8, and so on. If you're looking for, if the smallest the score is the better the object, then definitely T1 and T2 will be recommended or should be part of the recommendation to be recommended to the user. Okay, this is how TopK works, how TopK filter the other objects. Yeah. Okay, now looking at the scaling technique, it's another way of filtering the objects. So scaling technique retrieves the scaling, what we call the S, in a way such that any scaling S is not dominated by any other objects in the data set. So for example, if we have PI and PJ, again from the same collection, so we see that PI dominates PJ, this is symbol, if this condition holds. And what does it mean by this condition is that for every dimension that we have, if these dimensions reflect the criteria, okay, for every dimension that we have, for all the dimensions that we have in the list, the value of pi with regards to dk, for example, is greater or equals to the value of pj with regards to dk. Okay, so that means we need to compare the value of pi and pj with regards to every single dimension, yes. And there must be at least one dimension where pi, the object pi, has a better value than pj. So we say that pi dominates pj. So this is how it works. In other words, we have to compare. If you look at this example in figure 3, we have to compare, for example, T1 with T2, T1 with T3, T1 to T4, and so on. So just imagine we have a huge volume of data. There will be a lot of comparison need to be done. Okay, when we compare object to object, remember that, bear in mind that we are actually comparing the dimension, the value of each dimension. That means 4 is compared against to 7, 2 is compared against to 1, and 2 against to 3. And depending on our objective, whether we are looking for minimum value or maximum value. Yeah, so that's how it works. Okay, so this is scaling technique. So based on the example, T1 and T2 are the best objects, yeah, compared to the other objects. Okay, another technique called top K dominating technique. Now this technique sorts the objects according to the domination power that represents the number of objects being dominated, and retrieved K data items with the highest score of domination power. So top K means that we are interested with certain number of objects. For example, K is equal to 2, that means 2 objects. K equals to 3, then 3 objects, and so on. So over here, what we need to do is we need to do comparison and keep track how many objects that particular object dominates. For example, T1 compared with T2. If T1 dominates T2, then we increase the score for that particular object. So based on our example over here, you can see that T1, the score is 5. That means T1 dominates 5 other objects, and so on. Okay, so if you apply this technique, so based on this example, T1 and T2 will be the results, yeah, based on top K dominating technique. Okay, so this one is the K dominance technique. K dominance technique is whereby this technique retrieves these scalines based on a number of K dimension subspaces where K is less or equals to the total number of dimensions. That means we are not considering every dimensions in the analysis. Maybe some of the dimensions depending on the user. For example, some users might want to consider only D1 and D2. Some users would like to consider D1 and D3. So this is where we have the subspaces comes in. Okay, similar to the scaling technique, but instead of considering every single dimensions, okay, under K dominance, we only focus on certain dimensions. That's why if you look at this condition over here, we have there exists a D prime, which is a subset of D. Yeah, where D is actually in our examples D1, D2, and D3. So you're looking for something smaller than the list of dimensions that we have. Okay, so that's K dominance technique, and so on. I'm not going to go into details, the other techniques. Anyway, that's the brief idea about these preference evaluation techniques. So there are many techniques. Okay, the idea of every single techniques is to filter the objects where we know that these objects should not be recommended to the user, yeah, because we have better objects. Okay, now let us have a look, because my research work is based on scaling queries, so I'm going to go into more details on scaling queries. So evaluation of scaling queries. So we have over here, I'm sure everyone have seen this before. This is an SQL statement where we have, for example, select all, from hotels. So hotels is the name of the table where, so we have these two conditions, price is minimum and distance is minimum. So we are looking for an object which is under the category of hotels where the price is minimum and distance is minimum. If there is no object that satisfies this condition, so what happens is nothing will be displayed or will be sent to the user. Okay, this is the normal way how SQL works. Now using skyline is where we have a skyline operator or function. It's called skyline off. Okay, when you inject this one into the SQL, the previous SQL statement, now how the system works is a bit different. It will, if it couldn't find an object that satisfies this condition, it will try to find objects that are not being dominated by other objects with regards to these two criteria, yeah, price and distance, or these two dimensions. This is how skyline queries work. So instead of giving nothing to the user, it will recommend something to the user. So this is the beauty of skyline. Okay, now let us have a look at this example over here. It gives you a better clear picture about skyline, how it works. So now, for example, we have these objects A until F. So we have these two dimensions, price and distance. Okay, and then we put the objects into the space. So A is there and so on. So you notice that if you compare these objects, you notice that A is actually better than the other objects in regards to distance, because it is nearer to the origin with regards to distance, somewhere there. Okay, so it's the best object with regards to distance, and C is the best object with regards to price. It has the cheapest price, okay, because it's somewhere there. And E is in between. So if you compare, for example, C and F, okay, you compare C and F, you know that C is better than F with regards to distance. C is also better than F with regards to price. So no way, and you should not actually recommend F to the user if the user is looking for something which is minimum in terms of price and minimum in terms of distance. Definitely F will not be in the list. Similarly, B and D will not be in the list. So what we have is A, E, and E and C, because A is good with regards to distance, C is good with regards to price, and E is in between. So we can actually recommend to the user these three objects, and the final decision, well, the user will have to make the final decision anyway. Okay, so this is the concept of skyline. Okay, this is also another example. So skyline technique identifies a set of objects that is not dominated by any other objects in the data set. So very similar to the previous example. Over here you can see that M, L, K, and J will be the skylines. Okay, or the results. Okay, the issues. Okay, there are a lot of work on skyline query processing. The aim is actually to reduce the search space as small as possible by focusing only on the set of objects that may potentially be the skylines. The traditional skyline requires n multiplied with n minus 1 divide with 2 pairwise of comparisons. When I say pairwise comparison, that means if you look at this object over here, we need to compare A and B, A and C, A and D, and so on. So there will be n multiplied with n minus 1 divided by 2. So if you have even 10 objects, 10 multiplied with 9 divided by 2 will give you 45 pairwise comparisons. This is pairwise comparison between objects. And if you look at the attribute levels, it will be more than that. Okay, and it's the number of objects. So basically what we have is actually we have our data set, okay, and then we apply the skyline algorithm, and then you get the result, skyline object. So skyline algorithm will filter the object. A lot of researchers have come out with a lot of good algorithms that they actually pre-process the data first before it is being sent to the skyline algorithm, because what they're trying to achieve is to reduce the search space. Okay, from 2001, Stephen Bozoin is the first person who actually proposed skyline operator. Yeah, and then from there, and then we have a lot of other works that have been done that improve the algorithm proposed by Stephen Bozoin until Ilaria Bartolini. Okay, so what they have come out with actually algorithms, okay, at this level over here. So they prepare the data, the initial data, Okay, they do something with the initial, some of them, for example, using sorting, indexing, and so on. They prepare the data so that when the data that have prepared go through and they submit to the scaling algorithm, the number of pairwise comparison need to be performed is lesser than n multiplied with n minus 1 divided by 2. Okay. Now, this works. Assume that the data set that they have, there are certain data set without any missing values, without any uncertainty. It's a very nice data set. That's their assumption. Okay, now let us look at the works with regards to what happens if we have incomplete data. Okay, let us have a look what is mean by incomplete data or incomplete database. So if we have a database or a data set, and then we have this R1, R2, and Rn, where Ri is a relation, a database will have relations. Yeah. This will denoted by, for each relation, they have dimensions like this. So over here, I assume these dimensions are the dimensions to be used for a skyline or making decision. Other dimensions are not being considered. Okay, for example, address. Address, if you have a table that contains a column called address, normally you don't actually look at the address unless you're buying for a house. That's a different story. Okay, some of the columns are not needed for making this, for decision making. Okay, so D is said to be incomplete if and only if it contains at least an object pj with missing values. For example, like this, if you look at figure 1 over here, the dash 1, all these, we assume that we have missing values. Okay, so how to make decision if we have objects with missing values like this? So many reasons that lead into missing values which make the database incomplete. So incomplete data entry, okay, inaccurate data from heterogeneous data sources during integration, and so many other reasons. Okay, what is the issues with regards to scaling query processing when we have incomplete data? So the missing values influence negatively on the process of finding scalines, leading to high overhead due to exhaustive pairwise comparison between the objects in determining the scalines. Okay, the incompleteness of data leads to the loss of the transitivity property of scaling technique. The incompleteness of data leads to cyclic dominance between the objects, as some objects are incomparable with each other, and thus no object is considered scaline. Okay, example, if you look at this example, now we have these 3 objects. Okay, they have missing values. Okay, A have missing values in the first dimension and so on. So if you compare A and B, you notice that A is better than B, or A dominates B, as A is better than B. We assume that greater value is better in the 4th dimension. So if you compare this one, you notice that, well, A is better than B. So that means A dominates B. When you compare B and C, you notice that B is better, B dominates C. Now A dominates B, B dominates C. In the when you have complete data, you can only see that A dominates C. That is transitive property. Okay, once you have missing values over here, notice that C dominates A. So what we have is cycle like this. A dominates B, B dominates C, C dominates A. So none of them will be considered as scaline. So this is the issue when we have incomplete data in our data set. Okay, so a researcher called Khalifa and his team members has come up with an idea how to resolve this. It's called bucket and iScaline algorithms in 2010. Okay. Okay, now we have come out with another way of solving this problem, which is called the IncoScaline. So what we have is actually we prepare the data before we go into the scaline, before we actually apply the scaline algorithm. So we need to prepare the data first because our data is incomplete. Okay. So basically, these are the processes that we have come up with. We have clustering data, grouping, and finding local scalines, deriving k-term scalines, and lastly, we retrieve the scalines, and we get the results there. Okay, this is the algorithm. I'm not going to go into detail very quickly. So what does it mean by clustering data? As usual, clustering, that means you're grouping the data based on certain features. So in our example over here, we have missing values. You can see cluster number 1. Okay, cluster number 1, you notice that all objects having missing values in the first dimension will be grouped together, objects having missing values in the second dimension grouped together, and so on. Okay, this is very simple example. Actually, we have, if you have missing values in several dimensions, okay, you can have many clusters. So the best way to do this is to get the bitmap representation. Okay, every object will have a bitmap representation. You give a value 0 if you have missing values in that particular dimension. You give value 1 if the object has values for that particular dimension. For example, W1, the bitmap representation will be 0, 1, 1, 1. So all objects having the same bitmap representation, you put them together into the same cluster. Okay, as simple as that. So this is the clustering technique. So we cluster them together. The next stage will be grouping and finding group skylines. So over here, what we did is that based on each cluster, we create smaller groups. Why? Because we want to reduce the number of pairwise comparison. Okay, the more groups that we created, the more number of pairwise comparison we can reduce. Okay, so this is the idea. Groups are created based on the highest value of one of the objects in the cluster, the upper bound of a cluster, what we call it a UBC. The lowest value of the objects in each created group is determined, the lower bound of a group LBG. So very simple. What we did is actually, so this is the first cluster. Okay, so the highest value that we notice, we have 6, for example. So we put all objects with the same value 6 together. Okay, you can see there. These are the group where all objects have values 5, put them together, and so on. So we got this. So based on these small groups, now the number of comparison, now we have reduced actually the number of comparison. So now once we have this group, so now we can apply, and they have the same features or characteristics, right? Now we can apply the skyline algorithm. Okay, so we apply the skyline algorithm on each of this group. So this is actually the results, the local skylines of cluster 1, cluster 2, and cluster 3, and cluster 4. Okay, there's no problem at this stage to apply the scalar algorithm. There's no issue on transitivity property or cyclic dominance because all objects have the same characteristics. Okay, the problem is once we have these local skylines, and then to get the final skylines, we have to actually compare between these local skylines from different clusters together. Okay. So to do that, we come up with an idea of KDOM. Okay, we derive a KDOM, which is a virtual skylines that is being created based on other clusters. I'm not going to go into very detail. So basically, the idea is to derive KDOM like this. If you look at this example of it, these values come from the other clusters. Okay, we pick some values from this cluster, cluster number 2, 3, and 4, and then we create the KDOM, and then we compare with whatever objects that we have in that particular cluster. Okay, and then by doing this, then we apply the scalar algorithm again, and this is the result, the final skylines. Okay, x1, x3, and z4. Okay, that's the basic idea, how we actually solve the issue of processing scaling queries when we have incomplete data. We have made further extension to our proposed approach where we have, if we have, for example, distributed incomplete databases, how can we actually process the scaling queries when data are being distributed or located at several places. Okay, so I'm not going to go into this in details. We have the articles that if you're interested, you can always read the articles. Okay, and also we also have another idea where we input the missing values of skylines. And the approach that we use is by using the functional dependency. So there are many ways actually. We can always try to predict the values for these missing values. That's another approach to do this. Okay, this is the Dr. Ali Amir Alwan, who works very, very hard in this particular area, and we have a list of publications over here just to share with you. Okay. Next, if I still have time, I'm going to proceed to scaling query with uncertain data. Now, very quickly, I'm sure I'm short of time now. Now, if you look at this is extraction of web data. If you look at this data over here, you notice that some values are in range form. For example, over here we have US $1082 until 1197. It's in range form. That means the precise or exact values is not known. It can be 1082, it can be 1197, it can be in between. Okay, so that's what we call uncertain. This is where uncertainty comes in. Okay, there are many models of uncertainty with regards to scaling query processing. We can see that we have these two models. Uncertainty can be due to an object with many instances. Okay, this is the netball players. Okay, a player plays in so many games, so they have their number of assets. Some of the values, you notice that they are far away from the other values, so it becomes uncertain. Uncertainty can also be due to continuous values like this. Okay, when you have objects with values and the values are in range form like this, so we are not sure what is the exact values, so it becomes uncertain. Okay, so I'm not going to go through the formal definitions over here, but basically, if you look at figure 3, this will give you a brief idea about the uncertainty that we are dealing with. So if you look at object number 1, O1 over here under dimension number 1, dimension D1 over here, we have this range of values and so on. So how to make decision if you do not know the exact values for that particular dimension? This is a question that we try to address. Okay. So the issues with regards to uncertainty, data uncertainty, is that certainty and preciseness are lacking in the data, so imperfections of data. The exact values of the objects are not known at the point of processing, and one cannot derive the exact scaline but can only compute the probability of an object being a scaline member. Difficulties in identifying dominance between objects when the range values of the objects intersect. So if you look at this example over here, we have A and B. Okay, the value of the first dimension for A is from 200 to 600. And then this is the value for the second dimension and the value for the third dimension. So if you want to compare A and B, which one is better? It's very difficult to answer because this value 300 to 450 is actually a subset of the values under A. So A is better than B if definitely we know that the value of A is 200. A will be worse than B if we know exactly the value of A is 600, but we are not sure what is the exact value. Okay, so unable to conclude that object A definitely dominates object B and vice versa. So these are the people, the researchers who actually work under this issue. So we have branch and bound interval skylines, and then you have used chi. This is our solution. We call it sky code. Okay, this is the our framework. So basically what we have distinctive partitioning, exact domination, range domination, uncertain domination. There are three levels of domination testing needs to be done. Exact domination is applying the traditional scaling queries. Range domination is where we perform a domination based on range values. Uncertain domination where we have exact and range values are being analyzed together. So if you look at this figure over here on the left, these are example of data that we are playing with, dealing with. Okay, we have example one, we have so many range of values. Some of them we have exact values there. Some of the columns, for example, D3, for example, rating, you don't have range values. Okay, some dimensions definitely there won't be any range values appear in that particular column and so on. Okay, so with regards to that, very easy how to solve that. It's very similar. So if you look at all this research work, they have similarities. What they will do is group or cluster the data first based on the features. So if you look at this data, you notice that they have similarities in regard to some criteria. For example, like this, you can group those objects that do not have any range values like this. So you have group number 1. Group number 2 is whereby we have objects where the range values under dimension D1, where the values under dimension D1 are range values like this, and so on. Okay, it's very similar to the incomplete problem just now. Okay, so we group them together so that we can actually process them in much easier. Okay, now for group number 1, of course, if you look at this one, all values, they are exact values, so there's no problem to apply the traditional scaling algorithm. So we can directly apply the scaling algorithm and we can get the result. Object 12, object 33, and object 36 are better compared to the other objects. Okay, so we can filter all this. So you don't have to compare these objects against the other objects. Okay. And for this part over here, group 3 and group 4, where we have, they have homogeneous structure for each of the dimension. Homogeneous means if you look at D1, all of them have the same structure. all of them are exact values. D2, you notice that they have the same structure, means range values. D3, exact values. D4, exact values. The same goes for group number 4. Okay, D1, all of them have the same format or same structure. Okay, it's on the same structure. So we group them based on their features. So over here, then we need to compare object 23 to 24 and so on. So again, we have comparison there. We don't have any problem to compare when they have exact values. We do have problem when we have this one. This is where we need to apply probability theory. Okay. So once we have done that, for each of the group, this one we get the local skylines. So once we got the local skylines, means skylines for that particular group, then the best objects for each group are compared to each other to get the final skyline. Okay, how we do that? Now have a look at this example. Now over here we have two objects. Okay, now the value for object R for the x dimension is in the range form, while Q is the value exact value. So now we have different structure over here, but we know that if you're looking for the smaller the value, the better is the object. Definitely we know one compared to this range value, one is always better. So Q will be selected as skyline. This can be removed. That's no problem with that. And for this example as well, there's no problem with this example, although R has a range values under the x dimension, but we know that the value for Q under x dimension is 5, which is greater than the range values. So definitely this will not be the skyline. So R, because 2 is better than 4, 3 is better than 7, so definitely R is selected as skyline. There's no problem with that. Okay, if you compare this one, this is the case where both R and Q are selected as skyline, because if you compare one with this range values, one is better, but we compare under this dimension 4 is better than 9. So both have their own strengths. So R and Q will be selected as skyline. There's no problem with that. The problem when we have something like this where the value of 3 is actually in between the range values 1 to 5. So over here we have to apply the probability theory calculation. Okay, so using that probability calculation, you'll get some probability values. This probability states, for example, for this example, R is rejected as skyline since its probability, which is 37.5%, has fallen below, well, we need a threshold values, whether we 50% and so on. This is actually user will have to determine these values. Okay. So some probability values, then based on that probability values, then we decide whether to reject or to select that particular object. So this is the how we'll do the comparison. Okay, another example over here, 4 is between 1 to 5, so we have to calculate the probability, and based on the probability value, based on the threshold values, then we can actually decide whether to select or to reject that particular object. Okay, and so on. Okay, this is how it works. Okay, so this is how we solve the issue of uncertainty. When some values are in range forms, we do not know the precise value. And extension towards our previous work, sky code, we call it sky code T. This is for range skyline, range queries. Range queries means the user puts some conditions with regards to certain dimension. And for example, looking for a hotel where the price is between 100 to 200, for example, so that's become a condition. But the issue of range queries, when you have range, we might have objects like this. Okay, this is the range. This is the condition stated by the user. For example, looking for 250 to 450, and then we have objects like this. There's no problem for those objects that falls inside the space of the conditions, but we do have problems with, for example, like object C, whether we should actually consider C. Should we actually calculate D as well? Because there are, some parts, for example, H, some parts of H actually is within the condition, some parts is outside of the condition. So we need to calculate probability again. What's the probability or chances of H to fall within the condition stated by the user? So this is actually another research work that we have actually looked at. Okay. So this is the lady that worked very hard on this uncertainty of data. So we have published a few articles there. Okay, another research work, again, if I have time very quickly, this will be the last one. Okay, again, with the issue of uncertainty, we noticed that the probability-based approach involves so many probability calculations. Well, we need to calculate values against values, and objects, again objects. So it involves a lot of calculation. And then the threshold-based solution is also not a very popular solution because users will have to decide how many percent, 50%, 100%, and so on, because different threshold values will give you different results. Okay, so these are the work, right, that work on uncertain data. So this is not a solution. This is the framework that we have come out, Squid. So the idea of Squid is to index the objects first. It's a very simple example over here, toy example over here. So what we did is we index this using an X tree. Indexing means that we're going to put the objects together in the space. Yeah. So for example, over here you can see that we have MBR, and this is called MBR, minimum bounding rectangle. So objects that falls within certain MBR, we know that they have similarities. Okay. So I'm not going to go into detail that. I don't think I have the time for that. So once we know the MBR, okay, the objects that fall in each of the MBR, so what we're going to do is just to do grouping again. Okay, we're going to group those objects that have, for example, exact values in the same space, objects that have a range of values like this. Okay, this one and that one. And then those with exact values, we can always use scalar algorithm, right? The traditional scalar algorithm direct to know which one is better, for example, G and J, which one is better. But the problem is for this kind of values when you have range of values. So in this solution, we did not actually use probability calculation. So what we did, I'm going to go through all this in details. What we did is that we use the falsification method, okay, to predict the value for the range value for every single range values. So very quickly, so over here, for example, now A initially have range of values using falsification approach. We managed to get the exact value for A and then C and so on. So once we got this exact value, we can apply the scalar, the traditional scalar algorithm, and we get the results. But of course, the problem with this is because it is prediction, so the accuracy is not 100% accurate. Yeah, because if you have an object of value 120, and if you predict, for example, A 121, it gives a difference. If you predict it to 119, it'll give a different answer. So the prediction technique that we use is not 100% accurate. We are looking for, searching for a better prediction technique to get, as accurate as possible. Okay, so this is the guy who's working on this work. Okay, other techniques, if you want to explore, we have issues on data stream as well, where we have data keep on flowing, so we don't have fixed values of data like this. The objects comes into the stream. So what will be the best objects? That will be another issue. Yeah, so we have sliding windows and so on. So I'm not going to go to details because I don't think I have the time. So the issue is actually the recomputation of scan is right. We try to avoid computing. This is when you have multiple queries. Okay, we know that when you have data stream, we have many users. They submit their queries. This is what we call multiple queries. So you notice that they overlap. These queries overlap, and then you process. For example, you process this part of data. You process for this query. You also can actually use the results of this process for the rest of the queries that overlap. So this is actually the issue that we're looking at. Okay. Okay, this is the lady still working on that. Others interesting work is on dynamic and incomplete data. Dynamic means what happened now. We have a data set. You derive the scalines, and then some data change. Do you want to actually, analyze the whole data set again? I don't think that's a wise thing to do. So what we need to do is we try to avoid recomputing what we have computed before. Okay, that means we need to save some of the results so that when the data change, when the data set change, we only focus on the part that has been changed. Okay, and this lady is working on a very interesting topic, which is computing scalar queries. When we have group of mobile users, users, they are moving around and they have their own preferences they want to meet. For example, they are looking for certain restaurants, for example, and how can we actually recommend, or they want to make decision, we will help them to make decision to find a place for them to meet while they have their own preferences. And distance is also an issue. Yeah, because we do not want some user have to travel very far while the others is very near to the point of interest. Okay, so thank you very much. Okay, thank you. Thank you. So sorry if I take the
Thank you,
time.
Dr. Hamida. Yes. So, is anyone having any questions?
Yeah, hi, Dilip here. Hamida, Dr. Hamida, thank you. I mean, very great insights on Skyline. Is there any product implemented or open source this algorithm, Hamida?
Okay, we have actually come out with a prototype actually of recommending a package for traveling where we inject our solution into this product. And we have actually, if you look at, I think, I remember the product actually. So sorry. I have it in the list. Okay, this one, if I'm mistaken. Sorry. I have in the list.
Yeah, this. Now
We
I was
have
looking
actually
for.
sorry. So we have we have several products that we have actually applied for copyright. Yeah, it's already copyrighted, and then we have actually attended several exhibitions. And one is ICANN, and we got gold medal for that. Anyway, that product's only in a small scale. It's been tested in a very, very small scale because the data that we play around is just a small, I think around 1 million data. So we need to actually go further because it's a lab scale. We need to go further to the real scale. And of course, we need budget for that.
Right. No, no, I was just looking more around if it is open source algorithm to use or even in
No,
package or modeling.
at the
No,
moment, no. At the
no.
moment, no. Mm-mm.
Right, got you.
Okay, thank you.
Okay, thank you. Is anyone else having any questions? Okay, no questions, I think. Thank you once again, Dr. Hamida, for your presence and presentation.
Okay, thank you.
Moving on to our next presenter is Dr. Priyak Bandyopadhyay, Senior Data Scientist from Singapore, and his topic is streamlining visualization content to better handle large data. Hello, Dr. Priyak. Are you ready now?
Hi, can you all hear me now?
Yes. Now you are the presenter.
Good.
Please share your screen with us.
Yeah, I am sharing my screen. You just let me know once you do see the screen. But while it
Okay.
comes up, let me just mention a point. I'm not yet actually a doctor, so I don't have a PhD degree, just so that you know. And
Okay, I'm sorry for that.
yeah, let me know if you can see my screen.
Um, yes,
You can see my
yes,
screen.
it's visible. Yes. You can make it a full screen and start your presentation.
Yeah, right. So I will try and keep this as concise as possible. I'm quite conscious that we are actually running out of time. So I will start by giving a brief preamble around what is the purpose of coming up with this idea and then go on to present the actual idea. So the moment I speak of visualization standards, the first reaction that everyone has that we already have a suite of guidelines and standards in place. It's quite prevalent all over the internet. Why do we actually need someone to come and add on to that entire ocean? So, well, the answer is yes and no. We do have a number of standards that are in place, but most of it is around the aesthetics and the actual visualization part of it. While many organizations do have multiple projects and use cases that rely on sophisticated visualizations, and while most of those visualizations are being employed by standard tools such as Tableau, Power BI, or in more complicated cases, SVG is one of the tools. Most of the visualization guidelines that we have in place are mostly catering to the actual aesthetics, look and feel side of it, such as font sizes, colorings, chart types, and so on and so forth. So if I take an analogy, if I'm having a car, most of the standards and guidelines are actually determining how the car should look like, how the car should actually be colored, and so on and so forth, but not so much the inside of the car, or in other words, not so much guidelines exist on the actual engine of the car. What are the mechanical parts that are lying inside of the car. So that's where my proposal come into place. Not so much the outside of the visualization tools, but that's something which we already have, but more so on the side of what is lying inside of a visualization tools, the layers that actually contribute to the actual visualizations, the designing layer. And standards or guidelines on such designs of the visualizations are conspicuously absent. And that's why the proposal that I'm making has its own place. Okay, and now that leads us to the question that it does establish the pretext of the proposal, but why is that important? So that is an actually valid question. And to answer that, let's just try and reconstruct a typical scenario of a project in any other organizations. A large scale project indefinitely, invariably has a number of members working on it, among which the knowledge has to be passed on, transitioned, and a pretty much boilerplate situation is project members dropping off and onboarding on short notices, and in the process much of the knowledge gets lost out in transition, right? So this is where the standards that I am introducing in terms of the proposal comes very handy, because if we are having a similar kind of standards that we follow in coding languages such as C# or SQL even, or Python, it's a standard that all can relate to, and the passing on of knowledge in terms of visualization products become much easier, something that usual coders in terms of C# coders or Python coders enjoy, but not so much for visualization designers. So that's where the utility of my proposal fits in. We are trying to reduce inefficient handover as much as possible and make the transition of knowledge as much efficient as possible, and that in turn would ensure higher productivity. Now that gives pretty much the introduction of what the proposal is, and at times it does seem or sound very simple and quite common sense, but common sense is not, as we all know, common practice. So what this standard basically would introduce is just like in any other coding language, introduce some naming conventions that we can follow while creating the report level variables, and try and organize those around certain folders, and that's as simple as that. But with that, we would just see that how simple but effective things become with the help of it. And I will go in and introduce this concept with respect to a particular reporting tool, which is Tableau. As a concept, this is actually applicable to any such visualization tool. I'm taking Tableau as the one in which this is actually implemented, but as a concept can be extended to any other visualization tool. Now let's just see what this actually is about. This is a screenshot of a typical heavyweight Tableau report, and those of you who are already familiar with this tool may be able to relate, and someone who is not, I'm pretty much aware that this screenshot itself would look pretty overwhelming, right? A lot of data points, a lot of connections, and a lot of internal variables that's been created if you look at the left bottom side of it. The idea of this concept is just to make or introduce certain housekeeping rules by which this entire content becomes much more manageable and looks sleek. So what basically we are doing, again to revisit, name the variables according to a rule book or a guideline, a report, and the report level calculations are just being renamed according to which, and group those report level variables after we are renaming them under a number of folders, which will in turn just make things much neat and declutter. And with that, let's just look at the same contents that we were looking at. You would see that there are some simple naming conventions that we are introducing. So for any internal calculations in Tableau, we are actually going to introduce a prefix by which we would be easily be able to identify the variables that are only being used internally and not visualization facing. In turn, the ones which are visualization facing, and by visualization facing, those who are not so much familiar with Tableau or any other reporting visualization tool, visualization facing variables are the one which are directly thrown into the visualizations, and hence the namings of those variables at least has to be business friendly, right? So which is why the ones which are business friendly and visualization facing are being clubbed under a folder which is called the visualization facing calculations, while the ones which are not visualization facing are being given that naming convention with a prefix, so that a designer, once he is taking a look at this reporting tool for the first time, he would be able to identify easily which are the variables that are internal and which are the ones which are not. Hopefully this makes sense so far. I will give a little more explanation on the subsequent slides so that this becomes a little clearer. I'm also conscious of time, so I'm just going on to the next slide without spending much on this one. So with this kind of a concept in, the elephant in the room then becomes that it obviously implies much rework efforts on visualization products that we already have, in terms of the reports in Tableau that are already being designed are operational. That definitely does not abide by such design guidelines or blueprints. What would then be the approach to actually align those existing reports or pre-existing reports to this new blueprint? That's where an automation tool actually comes to the rescue. And this automation tool has been designed by me. It's been designed in Python and being shared on GitHub for anyone to actually consume it or even modify and enhance it as applicable. So what this tool basically does is that, as I said, we are already having projects in which high volume of complex reports already exists, and if we are looking at a manual rework of those reports, it amounts to around 120 hours of man efforts, right? Definitely not worth the pain. So that is where the automation tool that I mentioned comes into the play, where the elephant in the room is addressed to a large extent. So what this API or automation tool does is it picks up most of this heavyweight lifting in terms of the manual rework. All this naming or renaming of these variables that I introduced, that's being done automatically by this code once you run this API across a bunch of reports. And this basically in turn qualifies to be that silver bullet, that instead of doing the manual rework efforts, you're putting it into the code, and the code in return makes the necessary changes to align the existing designs to this new blueprint. And the best part of it is the visualization themselves, they remain intact, so there's no disruption, there's no distortion caused on the visualizations as such. So the ones which are already consumed by business or users, they never get to feel the changes that it undergoes. That's the best part of it. Now, I would have loved to give you a demo actually, but I'm running short of time, and I'm gonna stop here with the information that this entire proposal and the code itself has already been shared on my GitHub page. Whoever so feels this is an interesting piece of idea, please take some time and visit this page. And the API itself is also available on the same site, so that you can download it and play around with it by just running it across a number of Tableau workbooks that you may have locally saved. Just save this API on your same folder in which the reports lie, and just run the API, and that in turn will do the magic. So with that, I will come to the stop and open up for any questions should you have any. Thank you. Any questions?
Thank you, Dr. Priyak, for your presentation. Is anyone having any questions?
We haven't any question, but can you share your GitHub link?
Yeah, sure. I'm just gonna ping this on the chat window.
Yeah, sure.
Okay, no questions from anyone. Thank you once again, Dr. Priyak. I'm sorry, Mr. Priyak, for your presence and presentation.
No worries.
So,
Thank you. Thank you for your time. Yeah.
okay. So moving on to our next presenter is from Dr. Zhao Lobato from Cooper and Sachs, UK, and his title is The Impact of AI in Social Development Programs. Hello, Dr. Zhao. Are you ready with your presentation?
Oh, hello. Hi. Yes, I am. Can you all hear me?
Okay, yes, yes.
Okay. Yeah,
So
so
you are
can
the
I?
presenter now?
Yes, okay. I'll share my screen. Hi, can everyone see this?
Yes, your screen is visible and
Okay,
is
perfect.
perfect. Yes, you can make it a full
Yeah,
screen and start your presentation.
thank you very much. Yeah, so thank you, everyone. So my name is João Lobato. I am research director at Coalesce Sachs, and we develop AI tools for the third sector and public sector. So my background is both AI and also social development. I have worked in a number of research companies and for organizations like the UN, the World Bank, and so on. So this talk today is largely based on a book that we're going to publish next month, which is a guide for organizations to use AI, but specifically for governments and NGOs, charities, to use AI. If you want a free copy of the book, just drop me an email saying that you attended this talk, and I'll make sure to include you in the VIP list of the early release copy of the book. Yeah, so it's needless to say that AI has a huge impact in the private sector and has changed everyone's life so quickly and in ways that nobody really could predict. But when you look at especially the third sector and to some extent the public sector, we see that the use of AI is much, much more limited, even though there's a huge potential and there are some programs, of course, running. There's a big gap between what organizations, NGOs, and governments do today and how they could use AI to make it more efficiently, save money, and have a higher impact in the delivery of social programs. So in my view, there are three main gaps related to these. There are odds, but I think these are the crucial ones. The first one is the acquisition gap. So as we know, in the first 50 or 60 years, AI, going back to the perceptrons, and they were developed by academics working at universities. But what you see in the past decade, or at most 2 decades, the private sectors really hijacked these experts, and now every single, or pretty much every single AI specialist who used to work for universities now work for one of the big companies, one of the big tech companies. And mostly what you see is that the applications are not only done by the private sector, but of course attending the needs of the private sector. So that's a clear gap that NGOs and governments need to look at if they want actually to make good use of AI in their work. The second gap is related to this is the know-how. So even though there are initiatives like UNICEF has an Office of Innovation, the UN has another department for research, including AI, and there are a number of partnerships between Google, Microsoft, IBM, and charities. But the reality of these programs.
I'm sorry for the interruption. Can you make it a zoom in, please? Because the content is not visible properly.
Is it too small? I'm sorry. Is it better?
Yes, now it's good. Perfect. Okay, you can
Yeah.
continue.
I'm sorry. Yeah. Okay. No. Yeah. So it's the know-how. So when you work delivering public services, social development programs, it's not quite the same as working in selling a product or marketing a certain idea or concept. So there is a big gap there, and to add to that, when you look at the skills of NGO workers and government workers, they have a totally different set of skills usually. So they are experts on education, health and sanitation, public health, and things like that. And there is, of course, a massive gap in terms of technical know-how. That's not to say that AI has not been used in both public and third sector. So there are a number of apps powered by AI that have been helping doctors and nurses, especially working in difficult areas like conflict areas or refugee camps, for example, to diagnose diseases, to help farmers to manage crop, to again diagnose disease, to have a better understanding of local weather or where to sell their products. But these, they tend to be really ad hoc, one-off interventions. You have some really interesting examples of partnerships between universities and other organizations that look into developing the wealth indicators in areas where there's no census, there's no reliable data, using geospatial data analysis or natural language processing. So there are projects and that show that it's totally possible, and it can make a huge contribution to governments and charities. But there is a gap as well in terms of adapting the programs to the context of the third sector of delivering social programs. It's not. I mean, we could make use of the same algorithms, but the context is totally different. So there's no point having, let's say, a machine learning engineer working in an education project if this person has no background in the education, and also it makes no sense putting together an education specialist with machine learning engineer if they don't have common language. So they don't have any understanding of each other's field. So that's another issue that somehow needs to be sorted if you want actually to start using AI on a day-to-day basis. So make AI part of any project of NGOs or governments, make it part of their daily work. And also we have some larger issues which we see in the news all the time, pretty much every day, about how AI has been used, especially by governments, in violation of civil and human rights and reproducing prejudice, implementations that are totally flawed, that have no scientific merit, and in other ethical issues. But despite all these challenges, it is possible, even though we have a dilemma here. in one hand, you have governments and NGOs with smaller and smaller budgets to deliver social programs, lack of personal or qualified people, usually really tight time frame. They need to reach sometimes the whole population of a country, sometimes a population that's hard to reach. And of course, they need to provide good service. So these are the challenges that anyone working in the public or third sector, especially when you talk about the delivery of social service, face. On the other hand, you have AI that we know, looking at the private sector, that can address all of these challenges, but the gap is still there. We could, for example, look at okay, so how can you find possible solutions for that? So you could, for example, set up a department in each organization or each government department, and let's say AI department that would be in charge of supporting all the other departments. One of the big challenge of that is that it's very costly. It will be really hard to attract people who can get much better paid working for the private sector. And also you still have the challenge of having a bunch of specialists in AI who might not know anything about a certain area, and at the same time have specialists in certain areas that don't know anything about AI. So you still don't bridge this gap. You could think about, oh, let's train AI specialists, machine learning engineers, or so on, to become, let's say, health or public health specialists. But then that's going to be a massive investment in terms of time, in terms of money. And of course, you don't know if people would be actually interested in doing that. And the same is true if you look the other way around. What about training and educators to become an AI specialist? That's going to be, again, it's not really feasible. So what we've been thinking is, okay, so how can we ensure that anyone working for these organizations can, in a project cycle, use AI at any time without any kind of expertise? So just like, for example, you go to Google Translator and you're actually using a very complex algorithm that you don't need to know anything about. All you have to do is just upload a document and you get the result. So think about the same idea, but designed for the implementation, for the design, for the monitoring and evaluation of social programs. So that is really what we have been looking at. And really to turn upside down the tendency now that is to create a project to use AI. Actually, what we would like to do is to use AI at any project and make it part of the daily work of people who are delivering social programs. So that is really what we do at Coalesce Sachs. Now we are developing tools that can be as easy to use as a Google search. We have, you work with a number of different areas, from natural language process, from geospatial data analysis, to also simpler tools like statistical methods that can help us to have, produce better reports and also have better understanding of the data. And the idea is really to bring all these different solutions together. We have some of these ready and we are using some of them, but actually bring them all together in one single platform that's going to be essentially the project cycle of a program, from the design, from literature review, to consultation with stakeholders, to the implementation, to the monitoring and evaluation of the program. So very briefly, that's what I had to talk about today in terms of using AI in for the promotion of public good, for the promotion of social service. And I'm now happy to answer some questions or any comments that you might have.
Thank you, Dr. Ziao Labato, for your presentation. Is anyone having any questions?
Okay, so thank you very much for the time. I have to jump to another meeting now, but yeah, thank you very much for I had the opportunity to join a few of the sessions, and yeah, they were really interesting. Thank you.
Okay, thank you. I think there are no questions from anyone. So we can move to our next session, plenary sessions. And this plenary sessions is led by session chair Dr. Srirang Bhagavatula from Cinnamon Bay Servicing, USA. And I will just give a brief description about the session chair. Sriram Bhagavatula did a double master's in statistics, econometrics, and computer science with 20 plus years of specialization in providing predictive and prescriptive AI ML solutions architecture, decision systems design, development, and implementation of banking and financial institutions, spanning clients like Z, Consumers Finance, HSBC, Citi, RBC, Bank of America, Constellation Energy, HP, eBay, and PayPal, etc. Also published few research papers in international journals on mathematics and computer science. So our next presenter is Dr. Gabby Zodik from IBM Research, Israel. Hello, Dr. Gabby.
Hello, can you hear me?
Yes. Are you ready with your
Great.
presentation?
Yeah, if you allow me to share, I'll share.
Yes. Yes, you are the presenter now. You can share your screen with us.
Okay, let's see, takes a moment. Mm, I guess I'll need to rejoin in order
Okay.
for my Mac to allow it to share. Otherwise,
Oh, okay,
I
okay.
think,
Yes,
do you see
yes,
my
yes.
screen?
Yes, it's visible now.
Ah, okay, great. So you can see my presentation as well now? Is it okay? You see my
Yes,
presentation?
yes. You can make
Okay,
it a full
excellent.
screen and start your presentation. Perfect.
Okay. So in the next 30 minutes or so, I'll speak a little bit about blockchain, but really try to link it to data and AI and the relationships. And the more we make progress in these areas, you'll see that blockchain, in a sense, is a platform or a technology that enables various things that were not possible so far. And I'll get to more details, I guess. But one way to think about it is that we've done and we do a lot of AI and we have a lot of data within the organization and we apply various techniques. But when it comes to go beyond the organization, it's much more tricky because the data often doesn't belong to a single organization. Multiple organizations do business together, and you'll see how blockchain can help in this challenge. So as it was said, I'm from IBM Research. As many of you know, we have multiple labs across the world. I pointed out here the labs who work in the area of blockchain. Among other, one of my responsibilities is leading worldwide the blockchain team in research. And in Haifa in Israel, where we have the research lab, I also manage a department that has also work around various areas, but primarily around AI and blockchain and IoT. One of the main platforms that we are promoting within IBM is an open source platform called Hyperledger Fabric. It's under the Linux Foundation. And it's really a distributed platform that allows to develop blockchain applications on top of it. And it's been used for multiple solutions within IBM and our partners and our services teams. What you'll see through my presentation is more of the future directions in blockchain and how, again, they relate also to data and analytics, not so much about the existing capabilities that, again, I invite everyone to just go there and download the platform and play around, build the application, or ping us and we can help. The main areas I would say that we in research are focusing around are around distributed systems, around how to build more scalable consensus mechanisms, around security and privacy, and we'll see, I'll touch upon those in more detail. Now, I'm sure many of you already heard about blockchain. I think 2 points. One, the primary direction we're looking at is permission-based blockchain systems and networks. That means not just public, that many of you are familiar with, such as Bitcoin or Ethereum or others, but in most business cases, in B2B, when you deal like with bank, insurance companies, and so on, there is a business process that runs across multiple enterprises, and really blockchain provides or adds the ability to build the trust among these enterprises. And as I was saying earlier, one of the issues or one of the challenges in order to apply AI across enterprises is the fact that the data is private, and oftentimes the data has some competitive advantages to that organization. So just sharing the data across the network is not easily done. And blockchain allows that, and allows in general to create automation. The fact that we have this ledger that is shared across the participants creates a transparency and trust, because people who participate in the same transaction can see the data, the transactions, who signed, who created the transaction. But at the same time, it's trusted because from a security point of view, it's immutable. You have non-repudiation. You know exactly who signed every transaction and so on. Yet there are still challenges. I'm just highlighting a few that we are looking at. Okay, as I said, around the distributed part of the system, how to create that, how to preserve the privacy and still achieve scalability by meaning of multiple parties who can join the network, but also run many thousands of transactions per second. One of the topics, I guess, that most times you hear is this concept of tokens. And the token is really a fundamental abstraction mechanism. And in some other domains, we use just different names. But essentially, when we want to abstract in a network some physical thing, it could be something that, and you oftentimes hear that in the context of when it represents really money, but it doesn't have to be. It could be that it represents some object, some asset someone has. Essentially, anything that has value, has ownership, and you want to trade with. That's why it could be also securities, it could be digital rights, and so on. So token is a very useful concept, and that's why we spent some time to create this library, and it is open source, something that anyone can use and build multiple kinds of application much faster. Now, one such application that is emerging in the world is around digital currency, central banks' digital currency. And unlike Bitcoin, I would say that many of the countries in the world are looking how to digitize their financial systems. It could be in between the banks and the central bank, all the transactions that are happening there, but eventually it will also reach us, everyone, all the consumers. All of the interactions we have between us and the banks, or us and any of the places we go to do shopping or spend our money. There are multiple characteristics, obviously security, but also to some level anonymity, because the fact that I'm sharing the transactions I'm doing with my bank, and the fact that that bank is in a network with multiple other commercial banks doesn't mean that they need to share the information about myself with the other banks. It has to work, for instance, offline. It has to be very simple to use so elderly people can use it. It's not enough that just a youngster who know to use a smartphone can use it. We need to enable peer-to-peer payments very easily. So if I meet you and I want to transfer to you money, as I do today with cash, I should be able to very quickly and easily do those transactions with the digital currency, and so on and so forth. So all of this thinking is happening now, and there are multiple pilots. We participate in some of those, and many of the banks are trying those out. This chart just makes a little bit of sense to just position where the digital currency central banks, it's somewhere in the middle of this chart. You can see it somewhere here. And it's really in the intersection of what central banks are interested, but with all of the other qualities and dimensions that I just mentioned. If we look at how the network will be when we want to build such systems, so you can imagine that we'll have multiple networks in a country of retail banks connected among themselves and connected to the central banks, who in their turn are connected to other central banks of other countries. So some of the challenges that come up that we are looking at is how to integrate across these ledgers or these networks. And integrating and being able to, for instance, even just transfer data is not an easy task with blockchain and the reason for that is that you can just invoke a remote API as you would do when you build a distributed system. Because what usually you want is to get the guarantees of the network, of the remote network, about the data that you are getting. Meaning that you need all the proofs associated with that data, that it is indeed the correct data that was written, for instance, to the ledger. You cannot trust a single node there to just give you that. That node might be malicious. So the techniques being used oftentimes is zero knowledge proofs that are the kind of the metadata that is coming together with the data that provide enough proofs about the authenticity of the data. Other things we need to do across networks is not just transfer data, but do what we call atomic transactions. So you may want to transfer money between networks. So this might be 2 or more transactions in different networks, and they need to happen atomically, meaning that only if they are successful in both networks, they need to be written to the ledger. And so on and so forth. So these are kind of just in a nutshell the challenges. One other thing just to point out of things that we can achieve with these networks, and when we build up these abstractions with tokens, and this is just one of the projects we were involved in, is liquidity. So one of the things that blockchain brings beyond all the qualities that I just mentioned earlier is the ability to trade in assets that otherwise were not tradable. In this example, it's rare metals. So Atomize is a subsidiary of a large mining company, Nornickel in Russia, who mines rare metals like nickel, palladium, and so on. These are not usually traded in stock markets, and you as an investor, if you want to buy, it's pretty complicated. But with the blockchain, we actually released a network that allows to trade. So liquidity is another characteristics achieved. Now, I mentioned the importance of interoperability, and again, we don't have too much time to get into a lot of details, but I would mention that as we make more progress and we build more and more blockchain-based networks with all of the good qualities, as I mentioned earlier in the example of the CBDC, the central bank digital currency, we would need to put more emphasis on being able to create these interoperability among these networks so that we can exchange, as I've mentioned, data or transfer value. So here it's just a summary, and what you see at the bottom of this chart, and I'm happy to share it later on. Again, one of the open source projects called Weaver is exactly tackling these problems. And again, I welcome everyone who is interested to read or join the initiative. This is also under the Linux Foundation. I'm moving on. So one of the other topics or interesting topics that took a lot of interest in the recent couple of years, certainly with COVID, is around digital or decentralized identity. This has been an area of interest in blockchain for multiple years now. And there are multiple challenges in the modern world, but one of them is the fact that we have these identities that are spread across multiple entities within the country. It could be my health related data. It could be financial data related to the banks, insurance companies, so on. Could be my education, and so on and so forth. And everything is kind of distributed, and there is no way in which we today have a good handle over how to manage it. And all the efforts around digital decentralized identity management aim to give us, the citizens, back the power to maintain these identities and really share the data with whoever we want to share, but only that data that is needed to be shared in a safe manner, privacy preserving. And the example that you see here is really around COVID. And when COVID started a year and a half ago, we looked and we saw that we could provide a very simple and elegant solution based on blockchain for those who want to have a proof that they have been either vaccinated or done a test of COVID and have a negative result. Because today in many countries, you still get just a piece of paper or a PDF file that demonstrates that you've been vaccinated or negative. And of course, it's very easy to counterfeit and replace the name there and just show a false document. What is possible with blockchain is really the places that do, for instance, vaccines or the places where you do tests can create for you a certificate that's encrypted and signed, and you can go, and if you want to enter a mall or go on a flight, you can show that certificate, and the verifier can validate that two things. One, that the certificate is authentic, that it is really signed and encrypted, and all the data is correct, and indeed you are negative to COVID or have been vaccinated. And secondly, it can validate through the blockchain, in this case, that who signed the certificate is an authorized organization, maybe by the Ministry of Health. And that's the way we've implemented. This is actually running now in production in New York State and some other places in the world. And as you can see here, people go and they get, and certificates are issued by multiple organizations in the country, and there are multiple verifiers who can check that. It's a GDPR or HIPAA compliant, meaning nothing is saved on the blockchain, so everything is just saved on the phone. And you, as the citizen, can maintain and share it with whoever you want, but it is fully privacy preserving solution. One of the areas in order to scale and build these scalable solutions that really need to run many thousands, tens of thousands of transactions per second is around being able to run the consensus algorithm. Because as I said at the beginning, these are permission-based networks. And in these networks, usually we have a consensus algorithm who orders the transactions. And these have to be BFT, meaning Byzantine fault tolerant, because attacks may happen or malicious nodes may be part of the network because somebody attacked one of the organizations. And they need to be able to continue and scale and perform well even under attacks and even when the network grows. So again, this is yet another open source project called MIRBFT, and something that anyone interested can take another look. Another area to mention is the whole space of physical assets and how they can be linked to the digital world. And I think I already mentioned, so or if not, you can take a look at something like Food Trust is one of the networks that we deployed, and we have companies and like Walmart there, and we track and we provide all the traceability for all the goods that are transferred in the supply chain. But one of the challenges is that with blockchain, you can prove that this entity went through this and this, and it originated from this factory and so on and so forth. But it is as good as the data that is entered, meaning that if somebody steals or replaces the product with a fake one, you would never know. And in order to overcome that, in particular in the pharma domain, but not only, it could be also in expensive goods, where it could be diamonds, could be other prestigious fashion items and so on, you want to be able to link the physical object with the digital domain. And there are technologies called crypto anchor. And you can think of these as an RFID, but with a little bit more computational power to encrypt a secret key that is something that is not possible to copy. And it is attached physically to the object, to the drug, if it is in the pharma domain, or to the watch, if it's in the expense luxury products. And throughout the blockchains, throughout the supply chain, you can always, with a public key, check that that crypto anchor holds a valid serial number in that case. And with that, you can actually know that what the item that you have in your hand is the authentic item, and it's not something nobody replaced it. As I said, in the pharma domain, it's in particular very, very critical. I'll take one step further, and one of the directions that we see recently with blockchain and is that we started with blockchain, as I said at the beginning, that it creates trust among enterprises. And that trust is achieved by the fact that it has the non-repudiation and the provenance capability, the ledger that can hold transactions, and it's immutable and so on, and it is decentralized. What we observe, though, that in many cases, these networks, they do have a technology provider, such as IBM or someone else, and the networks actually runs in the cloud of that technology provider, because all the parties really trust that organization. And from that observation, we actually got to the conclusion, and others as well, that we could actually take a more common programming models, such as databases, and extend them with an additional layer on top of them that would give them all of the qualities that blockchain has: non-repudiation, provenance, and so on, immutable transactions and everything. Only that they run in a central way on the technology provider cloud, for instance. The advantage is it's much more simple to deploy these kind of solutions. And from a programming point of view, it's much easier because all people know how to program either relational databases or key value store-based databases. So the programming model is much simpler and easier. If I'm moving on, I've mentioned at the beginning that there is a tight relationship between AI and blockchain. And I think I said that one of the things that blockchain brings is the ability to actually run and get insight across a network where multiple enterprises participate, only that they have privacy concerns. They cannot share the data in the wild, in the open, because it is their competitive advantage. And oftentimes the entities in the network are in a co-petition. We know, for instance, that in supply chains, like in food supply chains, there is a huge amount of waste, up to 30%. And one of the reasons is that the retailers will not share the complete data about the demand that they see with the manufacturers or the resellers that bring them the goods, because they know that that reseller is also providing goods to their competitive retailers. So even sharing such a basic information of demand is not really possible. So with blockchain, we are able to actually preserve from one end the privacy and do computation across the network, and get insights from the data that is created through the network. And what you see here is really more of kind of a maturity model, all the way from more basic techniques. There is no single technique, I would say, to the more advanced things, right? And on the right-hand side, such as multi-party computation. But in some cases where data is allowed to be transferred, we can use homomorphic encryption and still do analytics. In other cases, we are able to actually do something around the trusted execution environment and transfer the algorithm that needs to be executed close to the data and provide and get all the proofs via blockchain that the correct algorithm was run on the correct data, and get all the benefits. So again, this is still in research, but so far we are doing various pilots in this space. Finally, and this is not strongly related to blockchain, but we did get more and more requests around this, is the data quality in general. When we run these networks, oftentimes when entities are willing to share some data, the data isn't at the highest quality that would allow us to get insights. And this data quality framework is being developed in order to improve the quality of data and incentivize the network participants to continuously improve the data that they are sharing, so that all will benefit from that, but they would also provide benefits or some incentive back for them to do those. So that's another area of research. And I think I'm kind of running out of time, so maybe I'll pause here. If there are any questions, I'll be happy to take them, and if not, I'm happy to stay longer on and take questions.
Thank you. Thank you, Dr. Zhao, for your I'm sorry, Dr. Gabby, for your presentation. Is anyone having any questions? Okay, no questions from anyone.
Dr. Gabby, how we can connect the blockchain with the digital twin. So what will be the future in terms of a digital twin for the blockchain?
Right. So I think digital twin, for example, is a term that we use in the IoT domain, in which we represent in digital form some physical objects. And I think this is strongly related to the topics that I've mentioned around tokens that are usually used as an abstraction in the blockchain. But tokens, again, is just one way to create those abstractions. So we can do that in multiple other ways. So that's one thing. And the other thing is that I gave the example of these crypto anchors. They also provide a means to connect to physical assets. And the third element, which I did not mention, is how to connect blockchain to physical IoT devices. So we have also developed a proxy, if you wish, that allows a sensor to connect maybe through a small gateway like an Arduino box or a Raspberry Pi, which can run actually a blockchain client and initiate transactions. So you can link all the way from these physical devices all the way into the transactions. So you can get all the guarantees needed that the sensor that produced the reading of that temperature is indeed authentic and correct and everything. So yeah, absolutely, this is possible.
Thank you.
Okay. I guess there is no more question. I'll be around, and also
Okay, no
feel
more
free to
questions, I
bring me.
think. So thank you once again for your presence and presentation, Dr. Gabby.
Sure, my pleasure.
Okay, moving on to our next presenter is Dr. Gaurav Gupta from Arogya Pandit AI Startup India. Hello, Dr. Gaurav. Are you ready with your presentation?
Yes, I don't have a PhD degree with me. You can call me
Oh,
Gaurav.
okay. I'm sorry, Mr. Gaurav. Okay. Yes, you are the presenter now.
Yes. I can't able to share my screen. You
Yeah,
made
can I
someone
know
else.
what?
Yeah. You have given the some
No,
presenter
uh,
command.
just a minute. It's from like it's okay. Yes, can you try now? I'm sorry for the
No.
mistake.
It's okay. Fine.
Yes, perfect. Your screen is visible to us. You can make it a full screen and start your presentation.
It's fine now.
Yes.
Yeah. Good afternoon, everyone. This is Gaurav from the Arogya Pandit AI group in India. I'm serving as a Chief Analytics Advisor at Arogya Pandit and having experience on the big data landscape, artificial intelligence, deep learning, and Internet of Things. I have published research papers and white papers in some of the reputed journals, and I'm serving as a reviewer in the Journal of Big Data. So these are the links that you need to connect with me. You can help these links as well. So first of all, before going into the presentation, I would like to thank organizing panel of this webinar for giving me this opportunity to express my views on the big data technology. And also I thank to the chairperson and enlightened audience for this wonderful session. So today's session, we will cover the big data, the types of the big data, and what is the real need of a big data, and the Hadoop's vendors, and the very important thing, how to design the trail of a big data. It means how you can create a real-time pipelines with the help of a big data landscape. The third one is what is the data lake, how we can design the data lake, what is the really need of a data lake in the terms of a data warehousing. So the fourth one, we can discuss the massive data set, the challenges that we will face to process any massive data or heavy data, and the ways to overcome those challenges that we will face in the daily life. Okay, the last one, the use cases and impact of industry. So these are the topics we will cover today. So first slide is the big data. So big data is calling why. So very important thing that what is a big data and why it is calling right now. So big data deals with the terabytes or petabytes of information. So if I'm talking about the huge amount of data, so then I would say the big data is the perfect one. In the traditional time, it was quite difficult to handle and process the heavy data with the help of traditional applications. But that the problem that hassle has been overcome by with the help of distributed computing, because the big data leverages the distributed processing. With the help of that, we can create a unifying data processing pipeline that will capture, analyze, persistence. You can do your query execution over that. You can create your cubing for the BI and for the identification visualization. Okay, and for the current the COVID-19 situation is already hit 50% of a rise in the data generation. So it will be 4x in the 2022. So best example of a big data is the NYSE, that is your New York stock exchange, that generates the 1 terabyte of a data in a single day. That's really a very huge amount of it. So second slide is a big data types. As we know that it's very basic things. There are the three types of a big data. The first one is structured data. When the data is in particular rows and the columns, and the perfect example of structured data is the Excel data. So that is coming from the mainframe, SQL Server, Oracle, DB2, Sybase, SAP HANA, Teradata, and other RDBMS systems. So that deals with your structured data. Unstructured data, that's the information coming from your multimedia files like the videos, images, and geotagging that covers the the conditions of unstructured data. The last one is the semi-structured data, the nested data, the JSON data, and any of the crawling operations you will do on the social media or on the any e-commerce site that will give you information related to semi-structured data. So need of a distributed framework. So distributed framework is very equivalent to Hadoop framework. That provides your distribution flavor to you can divide your load into a different in the numbers of nodes. So that nodes will help you to provide the distributed processing and give you a result in the parallel mechanism. Okay, so that's why from this graph we can easily see that the rate of the data mainly on the unstructured data is rapidly increasing year by year, and we know that in coming years the data rate will be populating raising up to 5x because of this COVID-19 situation. So that's why it is very important to massage the heavy data and extract out the indispensable information from that raw or massive data. So that's why it is very important to use any distributed framework. So these are the some distributor. From that we can leverage the flavor of a distributing processing. The Hortonworks, Cloudera, Mapr, IBM Watson, Amazon Web Services, Google Cloud, the Microsoft. The bottom three are the your cloud-based vendors that will provide you a functionality of your distributed processing. So alternative Hadoop frameworks, there are the lots of other stacks available in the market that will provide you a flavor of a distributed computer. You can use a Storm and the Flink, but both are very recommended for the real-time analytics, not for the batch mode. But with a combination of a Hadoop and Spark, you can deal with the Lambda architecture. The Lambda architecture means you can deal with your real-time, near real-time, and the batch mode data analytics. So that's why it is very recommended to use the Hadoop and Spark combination. So it is very important slide. I want to say the trail to design the big data ecosystem. So in this slide, the red color represents the paid services and the green color represents the open source services. So the trailing of any of big data pipeline divided is classified into the 7 categories. The first one is the injection, where you can inject your data with any of the tools using the Scoop, Kafka, Nifi, Flume, RabbitMQ, PySpark. With the help of these things, you can create injection pipeline. And the second with the data persistence, where you store your data, where you dump your data, that is related to data persistence. The third one is the cleansing, with uh, with any of the tools, with the help of PySpark or Python, you can cleanse your data. You can create your own programming code, and and leveraging that programming code with your data, live data, you can cleanse the raw data into your extracted data. The fourth one is your the processing. You can use the Hive, NoSQL DB, Pick, Hue, Drill, Spark to process your data and make it meaningful. Insight layer is related to you can write your machine learning programs for analytics purpose. You can create your own the custom data set and the custom database for massaging of and creating an insightful decisive layer. The sixth one is the visualization. These are the visualization tools. Some are on the open source, and some are in the paid services. With the help of that, we can create a beautiful graphs with the help of in the extracted data. The scheduling is very important. How you can bind our individual modules of the big data technique components with the scheduling technology like Uji, cron job, these are Airflow, Luigi, Falcon, Glue. These are the tools, the scheduling tools that will help you to create a workflow and create a unified individual pipeline. So the data lake. So as you can see that the data lake is like a pond, is a small pond that collect all the raw information. Let us suppose we have a multiple data sources, and the data sources is the heterogeneous file format. Some let us suppose like some data is coming from the Oracle, some data is coming from the JSON, some data comes out from the in the I would say that in the XML. So so data lake will help you to dump all the all type of informations in on a unified centralized layer. Okay, once you dump all the things into the data lake, you can plan, you can perform any of the massaging activities using the PySpark or the Python, and and create a linkage between them, the individual modules of data. So that will help you to provide you a artificial lake. On that you can create your flat data store. So this is the architecture, the real-time architecture. With the help of that, you can create your data pipeline. Okay, so it is based on the Horton blocks. The first layer is the data injection, the cleansing. As we can see that from the PPT, that the data is coming from the different formats: the SAP HANA, Oracle, MySQL, CSV, text file, SQL, and the Tally BPM. Okay, so so that is coming from the different the sources in the heterogeneous manner. So here the scoop and the talent and NiFi is used to inject that data and create and pass through that data into the data processing layer. Then the data processing layer leverages the Hive, Canox. So these are the security permission facilities available in the Hive to process the data and create a meaningful information from that raw data. The third one is the prediction and forecasting layer. With the help of the Spark ML and the PySpark, we can achieve any of the machine learning possibilities like classification, clustering, regression, and so on. And the last layer is the visualization. With the help of I'm taking the four example here, that W, the Power BI, QuickSense, and Looker, but we can use some other tools as well that is available in the market. So same as it is based on the cloud architecture that leverages the AWS, the Amazon Web Services. Okay, and similar, this is the Azure one. We can create the similar architecture, data pipeline architecture, with the help of Azure components. So this is the comparison between the data lake and the cloud data lake. Okay, there are two things here: the on-premise data lake and the cloud data lake. So cost is very higher in the on-premise, and in the public cloud, the cost is very lower. The complexity is very high. You need to spend months of time to configure all the things in a on-premise system. But with the click of of time, you can stand up your own cluster with the help of the cloud data lake. The skill set is very important for the on-premise system, and someone has some less skill set, then he or she can create the data lake very easily with the help of a cloud. Time to value is lower in the on-premise and the public cloud, that is higher. Elasticity is higher in the public cloud. Performance is very higher in the on-premise system, because that will give you a leveraging flexibility to configure your own services on the on-premise cluster. So this slide shows the challenges when to deal with the heavy data processing. So these are the challenges that I have noted down with the 6 points here. The high time and the space complexity while processing the complex data. The second, with the high memory consumption. So when you process any of the information, so that allocate the full memory of your cluster. So that is very time consume, that will increase the time efficiency as well, right? So third one, in the heavy read write operation while querying and the processing of a heavy data, need of a high configuration framework. If you want to process your data very quickly, you have to add more configuration, so thus that will increase your value, the cost value as well. So the fifth one is the low data retrieving rate through APIs, and the sixth one is the data latency with the BI tool. So it is very important, because without any visualizations, you can't interpret any of the things from the data. So BI, the visualization is very important. So these are the optimization techniques which can overcome the challenges that we have discussed in the previous slide. The first one, the high phone map reduce. Let me start with the first point, the hive on the MapReduce. As we know that the MapReduce is the sole component of Hadoop, so that will provide a distribution framework to divide your large data into a chunk, in the small chunks, and the process that chunks into the different nodes. That will provide you very efficiency in the processing. So this is the one of the method you can leverage Hive with your MapReduce engine, and that will provide you the distributing flavor to process your massive data. The second one is the adaptive live long process LLAP and Apache Tej. These are the advanced version of your MapReduce. As we know that the Hive on MapReduce has been deprecated in Hive 2 release. In the Hive 2, you can you can leverage the benefit of Apache Tej and the LLAP. So these are the in-memory and the DAG based framework to process your data very quickly. Third one is the leveraging Apache Kudu with Apache Impala, because we know that with the help of Apache Tej and LLP, it is quite difficult to manage the good performance in the change data capture. Okay, when you the second reason is to take the benefit of Apache Kudu and Apache Impala, because it provides a very good efficiency data retrieving rate when you connect any of the BI tool with your data storage. Okay, so Apache Kudu and Apache with Apache Impala will provide you flexibility to enhance the processing mechanism and create a better look for the change data capture, and also it will help you to retrieve your data when you connect any of the BI tool. So first one is the in-memory tuning with Apache Spark. So as we know that the Spark is the advanced layer on the Hadoop. So this is that will provide you 100% more processing speed as compared to your the Hive and the Yarn. The sixth one is very important, that if you are processing any of the information, if the data is in the particular format, like I would say that in the ORC format and the package format, so that will give you more um, overall performance in the form of for your execution. Okay, so main thing that helps you that ORC uses JADLib and Snappy algorithm for better compression. If you use ORC and Parquet instead of a other file format, so definitely that will provide you more efficiency in the terms of performance. The seventh one is the smart advanced data warehouse and data mart. It is related to the data warehousing, how smart you can build your data warehouse. It is very important. So you can classify your data in the particular dimensions and the fact, and you have to you should know about that what information is very important for you, and on the basis of a dimensions and the fact tables, you can drop out your lots of unwanted columns and the unwanted information from your data. So that will also help you to increase the query optimization. The eighth one is the leveraging GPU computation. Right now, we have a lots of GPU distributed processing with us, but most of the computations is being run on the CPU and some other processing unit. But if we leverage the GPU computation in the processing of a distributed computing, so definitely that will help to boost the performance as well. It will help us to boost the overall performance. So one of the example is the ice cream. The one is the Israel-based company. They have developed a GPU leveraged database system, so that leverages the benefit of the GPU to process your the heavy data in a time of a minute. So the ninth one is the introducing smart layer as a staging transformation layer. So it means like you can add another layer, the intermediate node. I would say the as node or a staging layer. If you have any complex query with you, you can pass through that query on that node, and after processing that node, that complex query on that node, you will retrieve the informations and pass through your main layer. So that will also use to boost your query performance in a big data domain. The Hadoop on cloud, as already we know that when we leverage the cloud services like Amazon Web Services, Microsoft Azure, and the Google Compute Platform, that will provide you more better performance as compared to your on-premise system, because they are using the SSD framework to provide you a very high input and output performance. So it is very important. One of the biggest challenges in the Hadoop as a service is that the configuration is very the flexibility to do any of the amendment in the configuration is very challenging thing in the on-premise system. But on the on-premise system, on the cloud system, but in the Hadoop system, on-premise system, it is very easy to change any of the configuration. The last one is the pre-building data processing through cubing. Um, we can leverage any cubing mechanism in between the staging and the production layer, the final DWS, like the Apache Kylin, Apache Druid. These are the key examples to handle the massive data through the cube. When you leverage this kind of the cubing technology, the data retrieving rate will be faster as compared to other thing. When you connect with your Microsoft Power BI, Tableau, and other BI tools. So this is a live use case that we have done for the US client, that the clients wants to consolidate all the information that is coming from the different heterogeneous databases. So they want to create it. They want to create a centralized data lake. So this is the one of the main business use case that we can see in the current time. Okay, so this is the high level component architecture. It classified into three categories. The first one, how you can pump up your data from the disparate data sources. The second one is the how you can create a data lake, ETL layer, and analytics layer. So you can leverage the AI the things with on your process data. The third one is the front end layer, how you can display your data in terms of visualization. So these are the return of investment of the things that if you deploy any of the things with the help of a distributing computer. User-centric dashboard is quite effective. Through that, the decision making is very easy. It will increase your overall performance, and that it reduce the technical risk due to the metadata management and the pipe traveling, and the improving the strategic decision making regarding the customer engagement and lifetime value. These are the key points that you can get when you deploy any of the things on the big data. So similarly, with the help of big data pipeline, we can create the IoT application as well. So we don't have it too much of time, so I'm skipping this one. So this is the another one, the IoT technical components is the one of the another architecture that we can leverage the help of big data and the cloud computing. This one is for the predictive maintenance solution architecture. We can use our Arduino machine and Raspberry Pi and create our own configuration based IoT machines, and data is can be handled with the help of data pipelines. When you extend the functionality of a big data, you can achieve this goal as well. The enhancement in the IoT that also be possible when you combine a lot of things like big data, cloud computing, AR, VR. So with the help of this combination, we can get a better solution for the digital twin. These are the futuristic scope of big data. Once we get the extracted data, the meaningful information, we can create AI models and deploy that models on the in the meaningful information to make the things more insightful and decisive. So predictive analysis can be possible. We can get the functionality of NLP. Image processing is also can be possible on the images. The classification, the expert system, the recommendation can be possible with the help of a big data. The robotics interaction is very that's is related to the digital twin IoT can be possible. So these are the big data scenarios that from where we can use the big data. First one is the telecommunication. In the telecommunication, we can use big data for the for analyzing the CDR, the calling data record, and we can also process. We can get the customer churn prevention model with the help of a big data and AI. We can use the decision tree and other random forest to create a customer churn prevention model. So that will help you to give us the idea when the company and any other employee will leave the organization. And similarly for the web and e-tailing, the recommendation can be possible. The example of a recommendation is the Yahoo, eBay. In healthcare, so lots of companies using the functionality of a big data, distributing computing and the computer vision to get to know about the tumor in the brain and the oxygen level in the brain. These kind of things can be possible with the help of these combinations. So Flexus, the Nest Bio, and our startup, the Arrogate Pandit, is also working on the same domain. So government is also using the US government and the Indian government. They have built software that is based on the big data pipelines. The US Army is using that one, and Aadhaar is totally based on that one. We can use the in the banks and the financial services to predict the models and the fraud detection. So these are the main banks is listed out here: the JP Morgan, RBS, and DBS. And retail is also possible, like for the key personal churn predictions can be possible with the help of this combination. That's all from my side. And if you want to reach out to me, so you can contact on this email.
Yeah, thank you, Mr. Gaurav Gupta, for your presentation.
Thank you.
Is anyone having any questions? Okay, no questions from anyone. So moving on to our next presenter is Mr. Edward McIntosh from Atkins, UAE. Hello, Mr. Edward. Hello. Yeah, hello, Mr. Edward. Are you with us? Okay, please allow me a few moments. I will be contacting Mr. Edward. So till then, we will move towards the next sessions, and it is presented by session chair, that is Mr. Sivaprasad Pathyakuni, HAB USA. So the next presenter under this sessions is Mr. Sisil Kumar Jena, Indian Institute of Technology, India.
Hello, am I audible? Am I audible?
Yes. Yeah, you are audible. I'm going to make you the presenter.
Okay,
Yes, you are the presenter now.
okay, right.
Yes.
Okay, right now I'm sharing my screen. I hope my screen
Yes,
is visible to
perfect.
all of you.
Yes, it's visible. You can make it a full screen and start your
Okay,
presentation.
okay, just a minute. Okay, it is good. I should say it is means it's late night. It is around 10 p.m. in India. So good evening all from all of the world people. So my topic for the today's discussion is a cloud to fog or edge transition to improve the IoT potential. So I'm working as a research scholar at IIT Guwahati in India, and my basically I'm is my working area is under development of energy efficient devices. So these energy efficient devices is actually used in IoT for betterment of means I mean because the IoT devices are more intensive to energy consumption. So we try to develop some we try to develop some circuitry which will be used in those devices to provide better energy efficiency. So the talk is basically related to how the IoT and cloud and the fog all are related to each other. So basically there will be I'm using a slash notation over here for fog and edge because both the technologies are more or less similar to each other. Okay, slowly we will know what are the difference between this fog and edge, and what is the difference between this fog and cloud, and how they are related to IoT means Internet of things. So most of the audience might means I hope everybody is knowing, because there are lots of people who are the background is generally means actually whenever I get the option to choose the topic, I am little bit confused about who are the audiences. So I just prepared the slide in such a manner that everybody can understand, even if a person with having slight knowledge on computer science itself, or any electronics itself also. So the basic talk is like this. So there will be these outlines, and the outline begins from whenever the internet starts, then how the what is an IoT. Then I'll explain about some IoT architectures currently running on, and then I will explain about the components that is involved in IoT formation, and slowly the things will be going on. I have collected the figure which is shown in the right side of this slide, uh, which is actually showing what exactly IoT mean. Okay, so you can see here this particular the center tab is showing application domain independent service, or we can say horizontal market, and other things whatever you see like healthcare, then transportation, industry, market, school, vehicles or smart homes, agriculture, everything is actually connected. Whenever it is connected, then we actually called it as an IoT or Internet of Things. Okay, so if you begin from the internet initially, if you see this figure, interesting figure over here, initially approximately in 1960, the concept of network has been formed. That means where you can connect two computers together to share some file among them. Okay, then the internet where the www, or well, we can say world wide web is developed. Then we can connect lots of, means many computer, they can share each other through wire devices, and they will share their files. Okay, so that time we called it as internet. And slowly the technology has moving forward, and we have some wireless devices gets connected to the internet. Finally, nowadays people's through their small mobile devices, and they can be connected to the network. And finally we are in the era where everything gets connected, or nowadays generally Internet of Things is called Internet of Everything. Means you can connect a ATM machine, you can connect your home to the network, you can connect your refrigerator to the network, or you can connect your even your car, even your coffee I mean coffee machine. So everything gets connected. So we are currently we are thinking that Internet of Thing is nothing but Internet of Everything. So nowadays the internet enabled or Internet of Things enabled devices are more popular, like Alexa, or we can say that Google has also developed several devices. I'm sorry, because one Alexa is there in my room, and he's just shouting whenever I'm giving the name Alexa. Okay, fine. So these are nothing but these are actually called the devices which are IoT enabled. That means they have some sensor. The sensor is getting the information from the environment, they process it and produce some output. Okay, so the Internet of Things, whenever we are talking about, is actually developed in the term which is actually coined by Kevin Aston in the year 1998. And he called it as he gave a very simple definition. The definition is like this: the Internet of Things has potential to change the world, just as the internet did, maybe even so more. Though this definition is not actually defining the Internet of Things properly, but still it has a depth meaning. If you go through it, then you can understand that there will be a depth meaning of this particular definitions. I have collected some of the definitions from different papers, which is listed over here. Though we are not going to follow these definitions, but I have one definition which can be easily means I mean everybody will like, or everybody will understand. That definition is given over here. And the definition says the Internet of Things allows people and things to be connected anytime. Actually, this is not there. This two is not there. This is mistakenly written. So allow people and things to be connected anytime, any place, with anything and anyone, ideally using any path or network and any services. So he has given us a very good figure in this particular paper, and this is something like this. So Internet of Thing is of anything or any device, anyone can anybody, or any path or any network. So this is actually the definition which actually defines that IoT. Well, so after the development of this concept, that's IoT definition, I would like to present some architectures of IoT. So there are several architecture has been proposed by different authors, but the basic architecture which is mostly used by everybody, means everybody the think means they are thinking like how we can implement the IoT. Before that, I would like to tell that suppose if you want to implement a concept. Means if you want to connect the components, let's say you have a smart home, and in this smart home you have lots of devices connected together. Okay, so then this smart home is again maybe connected to your maybe connected to some other neighbor network, maybe to your other office network, or maybe, and this may be connected to some ISP provider or something like that. So this way, these are the things that are that can be formed an IoT, and the interoperability between these networks plays an important role whenever you are thinking about the IoT architecture. So the first, um, I think something going wrong over here. Some sounds are coming. Anyway, well, I'm sorry. Actually, I'm seeing some noise. Anyway, so we are talking about the IoT architecture. So the basically this is of three layer. I mean the three layers are represented like this. There will be a perception layer, which uh, I'll just explain you everything about this perception layer. Then the next one is the network layer. Then the third one is your application layer. So the perception layer is actually consisting of multiple sensors. So I have written something about means this perception layer is the sensor sense the gather information about the environment, senses physical parameters or identifies other objects in the environment. So if you take a simple example about any smartphone devices, let's say you have connected a smart bulb in your home, and you know that there is a sensor connected to it. So you can just change the color of that bulb. So that sensor will sense your mood or your voice command maybe. So after sensing your mood or your voice command, then it automatically changes the light to particular color. So that is what the sensor who is listening to you, so that will be rest in your perception layer. Then the next layer, the perception layer is actually collecting the information from various sensors. I'm just talking about simple one. And then after collecting these informations, they are going to the network layer where the things gets processed. So basically this network layer is responsible for connecting smart things, network devices and servers used for transmitting and processing the sensor data. So after collecting those data, they are just transferred through this network, and it will be collected by the servers, and the servers are going to execute those information and means actually it process the information, and they will give you output. Finally, the application layer is actually responsible for delivering application specific services to the user, and which is defined in which the IoT can be deployed. So some business information is also included in this application layer, and it is basically application specific. So the application from various application to other applications, the the rule and regulations or the prototypes are generally different. Not only that, after this three layer basic architecture, some other architectures are also available, like there is a five layer architecture. They will be divided, they have divided the whole thing into five layers, where the perception layer and your network layer is divided into again three layers, sorry, two layers, that is processing layer and the transportation layer. So the transportation layer is actually transferring the data from the connected sensors, and this transport layer is basically implemented through, or we can say, a network with through different network like wireless, or it may be a 3G, or it is a LAN or Bluetooth like kind of thing. They collect the data and transfer it. In the processing layer, those data is get stored and get processed. So you can think about the concept of cloud computing, uh, where all the computing devices. I mean, the processing devices, which are generally responsible for process the data, will be placed in the cloud. And the sensors which are present in the perception layer collect all the informations from the background or from the by sensing the entire environment and sends the data to the processing layer where the cloud reside, and they started executing it. Okay, so then comes the application layer, which will be responsible for delivering specific services depending upon what application you are using, and the business layer will be used for managing the whole IoT systems and the privacy rule, business rules. So there are be a profit module, so these are actually implemented through your business layer. Okay, so after discussing about this architecture of an IoT, then we should understand what are the essential components. So, means whenever you are trying to build one infrastructure, IoT infrastructure, then you must have something with you which you can use for your use, means for the development of IoT or for developing that infrastructure. So the first component that is came into picture is called your sensors, and we always come across many sensors whenever we are trying to develop IoT devices or IoT infrastructures. So one such sensors I am showing in as a figure, that is called obstacle detection sensor. There may be sensors which are available called smoke detection sensor, then ultrasonic sensor, then thermo temperature and humidity sensor. So by using these sensors, our hardware devices are going to sense the environment, and from that data the actuator will act upon. So actuator is something like, an actuator is a component or machine system that moves the control to the mechanism or the system. So the actuator is actually means act whenever the data gets collected from the sensor. So some of the actuator like relay switch will be there, and water solenoid valve is there. So they are actually after collecting like whenever when we use this water solenoid valve, what will happen, the sensor which is seeing the water level in a particular tank maybe, that sends the water level and send to this valve, and the valve will understand that whether to flow the water to the tank or not, or to when to stop. So this kind of thing, so sensor will collect the data and the actuator will act upon uh, doing what next, like that. So these are the main component of your IoT devices. So no need to explain about the applications in a detail, means I don't feel that it is required to discuss about the applications. So everywhere you nowadays, what wherever you see, there is an
Stamina,
application of IoT. I mean, if you are using a
stamina,
vehicle, or you can
play
use
दोबारा ज्वाइन
your
कर।
mobile devices, or you are using your smart
दूसरा
home.
सेमिनार तो सुबह से
uh,
चल रहा है, हमने बीच में से ऑफ कर दिया, उनसे बात
Okay,
कीजिए,
so I hope
डॉक्टर।
somebody's mistakenly switch on his mic. Kindly please switch off, so that it will be a great help for me. Okay, thank you. So these are the applications of IoT. You can read about this from this particular paper if you need, because I know that everywhere, if you think about your home, or it may be your transport system, or any community, or any national, or you can say industries, home or personal use, everywhere we are actually using IoT. So a cloud-centric IoT means I'm just introducing the cloud concept over here. So after we understand the IoT, its infrastructure, its uses, I would like to introduce this cloud, because everything gets processed whenever we are thinking about a smaller IoT infrastructure. The things are processed inside the cloud itself. Okay, so whenever think about the cloud is actually containing all the computation devices, or we can say processing devices. So there will be one layer which is representing the IoT gateway, and other two layers which where the IoT devices lies, and another one is called the network layer. So here in the network layer, I have shown you some some symbols that is related to your different networks, like this is a Wi-Fi device, or we can say this is a Bluetooth or RFID. So these are actually showing the networks through which the sensors are connected. So here to show the sensor, I'm just using some camera, some car, or there may be a mobile or your smartwatch, or there may be a smart camera, whatever. So these are the IoT devices. I'm putting it on all together in the one similar layer, that is IoT devices, which is the lower layer of the entire cloud centric IoT. And the information which gets collected from this layer will be transferred to the network, and there will be IoT gateway who will pass these information to the cloud. And here the cloud contains several processing devices or maybe storage devices, whatever. So these are used for your processing your data over the cloud. Okay, so you can feel the distance from the IoT device and the cloud, because every time whatever information, let's take a simple example. In our institute, there will be, I'm talking about in Indian Institute of Technology Guwahati, there will be a concept called face detection app, or we can say we are just taking our attendance through face detection. So what we are doing is, whenever we are inside the territory of the department, we just open our mobile phone and take the photograph through that mobile phone, and that photograph uh, will be used for making ourselves means as an attendance, like suppose, for an example, if I'm not near the territory of our department, I'm in my home or in my hostel, then that system will not uh, does not take my face as the attendance present system, or in means we are not actually in the department. So what happened in particular in that case, maybe my photographs is taken by the mobile phone. Let's say this is my mobile phone. This mobile phone may be connected to somewhere in the server, where inside the server is acting as the cloud maybe. So whenever I'm sending my photographs through my mobile phone, this photograph is going for the authentication purpose, whether that is me or not. Then that will be getting processed in this cloud. Then the result will come back, and I am present in in my department. Maybe that is the case. But later on, it is sometimes happens that the network is not proper, and the connection may be disconnected. So what they are doing is, in this particular app which is present inside my mobile phone, they have just taken a concept of I can say the concept of offline attendance. So what will happen whenever I'm in the territory of the department, he just take the photographs, and instead of sending this photograph to the cloud, maybe he can process it inside the mobile devices itself, and immediately I'm getting in my department. Okay, so that is the concept. So either you can send the processing devices to the cloud, or you may process it inside the mobile devices itself. But previously what happened, generally all communications are taking place through cloud whenever there is a cloud centric IoT devices. Okay, so that's all that we are I have written over here, so no need to read about these points. Whatever I have explained, that is called the cloud centric IoTs, where the data gets collected from the sensor and sent to the cloud, where they get processed over there, and the result is coming out. So what is the challenges in this IoT requirement? So there are several challenges. I have collected 5 challenges from different papers. So these challenges are that maybe that is called stringent latency requirement. Second one is called your network bandwidth constraint. Third one is your resource constraint devices. Then connectivity to the cloud, and new security challenges. So the points itself explaining something. I mean, it's just like I told you that connectivity to the cloud, which is one issue with that example I have explained. Some devices are resource constrained, means they have not sufficient processing capabilities. So maybe there is a challenge. There will be some network bandwidth constraint. That means the network is not proper. The data could not be transferred from the sensors or the IoT devices to the cloud. Then a latency requirement is there. Obviously, if it is it is like network, then obviously the latencies will be there, which is taking as a bottleneck, we can say. And whenever we are thinking about the IoTs, there will be new security challenges also arises due to this concept. Okay, like if you think about the several movies in Hollywood or maybe Bollywood, you might have seen that some movie has shown you that a pacemaker is installed in the heart of a man, and somebody has captured captured that, means the functioning of that heart is captured by somebody, and he is trying to control the beat pulses of that pacemaker. Sometimes we are using in our vehicle, in many movies it is showing that in a car there will be a device which is connected, which is controlling the car, the speed breaker maybe. So that will be controlled by some unauthorized person, and the car get crashed. So those kind of new security issues can be there. So basically these challenges has to be means handled through IoT or the cloud, whenever the cloud infrastructure or IoT infrastructure will be developed. Well, then the overview of fog and edge computing, as I have already told you, that the the actually, if you think about the fog, it is some devices or some processing devices, or we can say network devices, any devices which are actually closer to the sensor, or even the sensor itself, we can say, and that will be acting as a fog, or the, we can, this service which can provide services instantly without sending the data to the cloud. So that is the main concept of fog arrays. That the difference between fog and edge lies how much distance from the sensor the processing devices are. If the processing devices are inbuilt inside the sensor itself, then we can say it is called edge computing. That means the sensor collects the data immediately from the user and try to process it over there and send the result to the user. If he cannot process, then he will send the data from the sensor and send to the fog, which is closer to the edge devices, and process over there, then gives the data. If that is also not possible, means the processing capability is not enough, then we can send the data to the cloud. Okay, so this is how the things are getting connected. So for fog stands out along three dimensions. So generally whenever we are talking about fog, it is actually differentiated from cloud in three different aspects. So this carry out substantial amount of data storage at the near of the end user, rather than storing data only in the remote data centers. As I have already told you that the fogs are generally closer to the edge devices. So whenever the data are generated from the sensor, it just get submitted to the fog layer, where the data gets collected and stored over there. Then second aspect is your carry out a substantial amount of computing and control function at or near the end users. So the fog devices which are present are capable of processing some informations which are not complicated, or which does not require much energy consumption. So those kind of executions can be done inside the fog layer. And third one is carry out substantial amount of communications and networking at or near the end user. So basically he can capable of storing data, he can capable of compute or control the uh, entire communication, and finally it will be having a capability of communication and networking. So this is actually defining the fog computing. So a model of fog computing could look like this. So there will be some end devices over here, which is showing in the lower layer. Then the fog devices. Fog devices are consisting of means they are communicating with each other to process the data. Above the fog devices, there will be a core IP network, and then the cloud. So that means if you just try to include the edge concept over here, it is easy to implement. Let's say if you think that what is edge computing, then you can say that these devices, whatever devices you can see in this lower layer, that may be your smart camera or maybe a smart watch, that if some processing capabilities can be handled by these devices in the same layer itself without transferring the data to the fog, then we can say here the edge computing occurs. Okay, but whenever these processing devices at the lower layer are not able to or not capable to process those data, or they may not be able to store those data, they can collect the information from the environment and just send to the fog layer. So this is your fog layer maybe. So this fog layer have some fog devices. So this fog layer will collect those data and try to process over there, process over here, and try to send the result immediately without sending to the cloud. Or it depends upon the architecture or your phenomenon, so that you can either you can transfer the result and everything to the cloud or not. That is depending upon your infrastructure or your implementation style. But if the layer, this layer itself can process the data and send those data to the lower layer, then that is actually called fog computing. And even the fog devices are energy constrained devices, so they don't have sufficient amount of energies to process it, so they may send the data to the cloud whenever they are not able to process it. So we can say a single point over here, that fog is not designed, or fog or edge is not designed to remove the concept of cloud, or we cannot eliminate the cloud, rather we can improve the potential of this cloud system. Okay, so it is not to eliminate the concept of cloud. So there will be some differences I have collected from the paper itself, so no need to discuss those things, fog and cloud difference. But if you have a simple explanation about fog and cloud, it will be something like this. So if you are using a smartwatch, then you can say you are in the fog layer, or you can even the data can be processed over here, and smartphone is acting as a cloud for you. Okay, and if you are using a smartphone and it is connected present inside a car, and you are accessing the everything, every information from the means the car is sending some data to your phone, then we can say this is acting as a fog and the car is acting as a cloud for this entire device. When the car is traveling through the road, and the car is communicated through different traffic control systems installed installed in different places of that road, then this could be acting as a cloud and this could be acting as fog node. Okay, so this is how it is differentiated. So some points I have collected to define the fog and cloud are independent and they are mutually beneficial. We cannot remove one or anything. So these are the slight difference between fog and cloud. And I have already explained what is the difference between fog and edge. Well, so how the main topic of this discussion is how this fog is actually improves the IoT potential. So there will be, I have already discussed 5 different points, that is latency requirement. So whenever you are thinking about the latency requirement, how the fog can improve it. Fog performs data analytics, control and other time sensitive tasks close to the end user. As I have already told you, the fog is actually closer to the, or it is present in the edge of the network. So they are actually this latency constraint. Latency means sending the data from the device to the cloud will take much time if you think about the fog. So fog is immediately as it is an immediate device to the sensor, so he can just control the entire data over there and can process it immediately, so that latency requirement problem will be solved. And the second one is called the network bandwidth constraint. Obviously, the bandwidth will be acting as a bottleneck. So whenever we are thinking about data processing, fog enables hierarchical data processing along the cloud to think continuum, allowing processing to perform where it can be balanced between application requirement and available network and computing resources. This is also reduces the amount of data that need to be sent to the cloud. How it is reducing the data, because as I have already told you that if all the data need not to be sent to the cloud, and if you are not sending the much data to the cloud, then obviously the bandwidth requirement will be lower, and some data is getting processed in the fog layer itself. So this is how the network bandwidth constraint problem will be solved. Then the third point is called the resource constraint devices. So as we know that the devices which are implemented through IoT are not that efficient or not that energy efficient or processing efficient. So this problem can be solved with fog nodes itself. So you can just put any device in the fog layer which is slightly more advanced than the edge devices. So that resource constraint problem will be solved. Then the last one is called uninterrupted services with intermittent connectivity to the cloud. We can say a local fog system can operate autonomously to ensure non-interrupted services even when it has intermittent network connectivity in the cloud. So if the connection is not proper or intermittent, so the fog layer can help it over there. He can operate autonomously and can keep the data or the track of the information over there, and finally whenever it is necessary he will send the data to the cloud. Finally, there will be some security challenges, though I'm not aware of what are the security challenges. I'm not gone through it properly. So I have just collected some points regarding the new security issues. Something like it is act as a proxy for the resource constraint device, and it performs a wide range of security functions such as malware scanning, resource constraint devices, and all. Then it can use for monitor or security status nearby devices. So this is another point. I'm not sure how these points can be explained properly, but file system is capable of handling those security challenges. So the fundamental questions over here is mainly somebody may be thinking about which task should go to fog. Means even whenever you are thinking about an IoT infrastructure, there will be sensors connected. Those sensors are collecting data. They are sending this data to the fog layer. Then fog layer might be sending the data to the cloud. Please kindly mute yourself. Okay, so I'm running out of time. I have to complete it by half an hour. So which has to go to the processing? Those requiring real time end user low cost processing. Okay, it's well. So which should go to the cloud? So whenever you're thinking about cloud, then whenever you require a massive storage or heavy
Yeah,
duty
hello.
computing or wide area, yeah, hello.
Yeah, hello, Mr. Sisir Kumar. Can you please
Yeah,
hold for a minute as there is lots of disturbance?
yeah.
Okay.
Is the disturbance from my side?
No, no, no.
Okay,
Yes, it's perfect now.
okay,
Please continue.
okay, okay. Thank you, ma'am. Okay, so the fundamental questions over here is just I'm talking about is who does what. That is the main questions behind it. Means whenever I am collecting the data from the sensors, from different sensors, where should I send the data? Should I directly send it to the cloud, or without sending the data to the cloud, can we process it in the fog? So these are the different questions come into our mind. So there are simple answers, but it can be implemented on the specific applications. So whenever we are trying to implement one application, we just think about which type of data need to be processed in the cloud or which type of data need to be processed in the fog. Let's say which task would be go to the fog. So I have just written a simple point: those requiring real-time processing, end user objective, or low cost leverage of ideal resources. So if you want instant output or real time processing of anything, then you can just process it in the fog itself, or we can say edge itself. Edge means your sensor devices itself. If we could put some processing capabilities to that device, they will collect it and process it immediately and give you the result without sending the data to the cloud. Then which one should be going to the cloud? Because we know that edge devices or the sensors are not capable of handling or processing the data instantly, because they are battery operated and the energy is very low over there. and they have very low quality of processors we are using, means low capacity of processing. So whenever the data is massive or that you need heavy duty computation, or it is a wide area connectivity, then you need to send the data to the cloud. So which goes to the thing, means I am talking about that edge devices, how fog, the cloud and the things should interact with each other. So these are the basic questions. But if you think about the connections, the connection is actually something like this. There will be four things, I mean four important components of this entire communication: fog as an interface, and where the fog is actually acting as an interface. As I have already told you, there will be fog devices, they can communicate with each other. So those interfaces called fog to fog interface. If the fog is actually connected to the things or user, we can say the sensors, then that interface is called fog to thing interface. Sometimes the data may pass through without means going through fog. It may be acting as a proxy and the data is directly communicating to the cloud, then we can say that interface is cloud to thing via fog. And if the data is transferring through from the sensor to the fog, and fog will be communicating with the cloud, then this interface is called your fog to cloud interface. So these are the definitions actually, so which is written over here. Now I have already explained about edge devices. As I have already told you, there will be an edge layer over here. In the previous figure, I just told you that you can think it as the edge device over here. But just I'm trying to separate the devices, something like this. So there will be an edge layer for instant processing. You may send the data to the fog layer. Fog will be taking some more time to process. And finally, the last one is the cloud. Whenever there is a massive operation, you can go to the cloud. So there are some open issues and research directions over here, so that I am just written point wise. So everything after understanding what is fog, edge, cloud and how they are related to IoT, I just written some open issues or open research directions where you can go and try to discuss. That is deployment issue, how the things are getting deployed, how exactly the devices are deployed in different layer. Then you can just modify the architecture, or you can introduce new architecture, new layer in the architecture to standardize the IoT architectures. There may be the interoperability issue, because there are several networks are connected together. Some network have lesser bandwidth, some are more, and then the interoperability issue will be there. And whenever you are thinking about the network, then obviously the resource management is need to be managed along with the failure management. There may be communication between different layer, you can work upon over there also. And finally the security and privacy, these are the different open research areas. Several papers has been published in these areas, and some are in the infant level itself. So anyone can go and start searching in the internet and can start doing research on this. So finally, I would like to conclude my talk over here. So the fog computing paradigm is currently is in its infancy. So an intensive investigation is required for this emerging technology. So I don't want to include much of the conclusion over here. So anyone can go and go with this. With this, thank you for listening so patiently.
Yeah.
Yeah.
Thank you, Mr. Sisir Kumar Jena, for your presentation. Is anyone having any questions?
Okay, so my contact information is there. You people can contact me anytime. This is my mail ID. You can contact. Recently, I have just published one book in Taylor Francis. It is about to be published by December. So if anybody interested, you can go and look into this book. It will be a very good book. It is written around 2 years. It takes for writing this book in a proper manner. Okay,
Okay.
thank you.
Thank you.
Yes,
Thank you once again for
yes,
your presence and
Shishir,
presentation.
Yeah,
yeah, Shishir, one question is:
yeah.
are there any, I mean, parallels with Amazon wavelength as a service?
Can you repeat the question, please? I'm not able to hear
Amazon
that.
wavelength, uh, is it parallel to Amazon wavelength as a concept?
Amazon wavelength.
Yeah.
Actually, no, I'm not sure actually. Just I'm
Okay.
not. My work is actually developing some resource constraint devices or energy efficient devices, which will be used as a uh, means in the IoT layer, means the lower layer, which will take less energy and compute more. So that
Right.
is actually
Got it.
we are developing the devices for edge and fog layer. So that is the main work of our.
Sure. Sure. Thank you.
Okay, thank you. Thanks a lot.
Okay, thank you, Mr. Sisir Kumar Jena, for your presentation.
Thank you,
So,
ma'am.
as this session is led by Mr. Sivaprasad Patnyakuni, I want to give a brief description. He holds a master's in computer applications with total 20 plus years of software engineering experience. Sivaprasad have been developing predictive analytics uses cases using machine learning algorithms for domains like railroad, banking, user behaviors, and retail market. Sivaprasad have been working on integrating data pipelines to Azure and AWS cloud and processing data. He has been mentoring many technical teams and inculcating best practices. So the next presenter is Mr. Christian Philipp from University of Oldenburg, Germany, and the title of her talk is State Classification of Wind Turbines, an Unsupervised Method Using the Kramers-Moell Coefficients. Yeah. Hello, Mr. Christian. Are you ready with your presentation?
Yes, I am. Hi.
Okay. I'm going to make you the presenter.
Yeah.
Yes.
So you are all
Now,
able to hear me? So my audio is fine?
yes. Yes,
Oh, fine.
perfect.
So, and now you can see my screen, my presentation?
Yes, perfect.
Perfect. All right. So, hello everyone. I'm Christian Philipp. I'm a PhD student from the Karl von Ossietzky University in Oldenburg in Germany. Wait 1 second. No, now you can see my laser pointer as well, right? So, okay. Yeah, I take part in the so-called Visa Big Data project together with my supervisors, Dr. Matthias Wächter and Professor Dr. Joachim Peinke, who are from the Forward Work Group in the University of Oldenburg, and also Dr. Jan Freund, who is from the ICBM Work Group from Oldenburg. Yeah, oh, I'm sorry. Ooh, this was too fast. Yeah, I'm going to present the state classification of wind turbines, an unsupervised method using these Kramers-Moell coefficients. So in this presentation, I want to explain to you what these Kramers-Moell coefficients are. So these are basically the coefficients which are used for stochastic differential equations. And I want to show you why we can use them. And then, like the title suggests, I am going to show you methods, how we can use these coefficients for state classification of wind turbines. So these wind turbines is really just an example here. I think this is also doable for other systems and other systems. But yeah, let me jump in this presentation. So first, I want to introduce you to the Visa Big Data project. So this is short for Wind Farm Virtual Site Assistant for Operation and Maintains Decision Support Advanced Methods for Big Data Analysis. And as you can see, there's even big data in the project name. And just to give you brief information on wind turbines, so we can say that roughly about 20 to 30% of the cost of wind turbines are in the operation and maintenance of these wind turbines. And the idea is that if we can lower these costs if there are better methods for the state classification or even the early failure detection for the wind turbine. So the state classification would be something like at this time this wind turbine is working okayish or there are some faults at the moment. And the early failure detection would be something like, okay, in let's say 2 weeks or something like this, the rotor of the system will have some issues which you can forecast. And typically, the state of the wind turbine is observed via a condition monitoring system or a 10 minutes averages of supervisory control and data acquisition operational data, which is short SCADA data. And in these recent years, methods methods to analyze 10 minutes SCADA data were studied, but were found insufficient for early failure detection due to the poor time resolution. In our work, in our project, in this visa project, we are using temporal highly resolved SCADA data in order to improve the state optimization and by that the early failure detection. And these temporal highly resolved data are usually stored by the companies who are working with the wind turbines, but so far they are not widely used. So just to give you a few image on what I'm talking about here, I've plotted a time series here. So this time series X over time T over time, where I call here this blue line high resolution. This is like with the resolution or temporal resolution of 1 Hertz in comparison to this orange line where we have one value each 10 minutes, or this green line, which is used in wind turbines, where we take the average over 10 minutes each 10 minutes. And what you can see is that we have a lot of more information available if we are using these high resolution data. And in fact, what we need for our methods, we need to see the fluctuations of the system, because these Gauss-Minimal coefficients, which come from the stochastic differential equations, so to measure these, we need a stochastic system, so we need to be able to see these fluctuations. And yeah, and now I want to continue with a little bit of math so we understand what I mean when I'm talking about these stochastic differential equation, or especially the Schlangenberg equation. I try to do it as less mathematical as possible, but I think a few formulas are needed here. So if we look at the increment of a variable x over time lag tau at the time t, this can be calculated as as x of t plus tau minus x of t. So we adjust the increment, which can be described as the integral from of t to t plus tau of this d1, which is the first Gauss-Minimal coefficient, or also often called the drift, at a specific state dt, plus the integral of t plus tau from t to t plus tau of d2, which is the second Gauss-Minimal coefficient, or also often mentioned as the diffusion, dw here. Here, this dw is a Wiener process, but to break it down, it's basically on left-hand side here. This increment can be described as a tendency of the system plus some noise. And if we have a system with Gaussian white noise, then these two parameters are enough to describe the whole system. So if we have the drift and diffusion, so this d1 and d2 term, we can plug this into the Fokker-Planck equation, and then we have the probability density function. And if we have this function, we have basically everything to understand the system. So everything what we need, if there's really this Gaussian white noise, then all what we need is the drift and diffusion. Maybe one more picture that you understand how this works. So in another time series on the left side here, with the variable x plotted over the time t, which is fluctuating here, goes down and goes up, and then we can zoom in the later area here. This is plotted in this right-hand side window here, where we see the single values of the time series. And here at the end, we have some kind of a drift value which decides the tendency of the system and adds a random number basically drawn from a normal distribution. And this is basically how this time series from a Langevin equation can be described. And to give you just an idea how the drift values can be described, I have here an example from the German Autobahn. where we basically looked at the frequency of the cars and the speed of the cars. So here on the y-axis you can see the frequency of the car, so how many cars per second were there locally, and the speed of the cars. And these arrows represent the two-dimensional drift field of the car frequency versus the speed. So you can read it if there are, well, let's say here 0.7 cars per second with a speed of roughly about 60 kilometers per hour, then the system has a tendency that the car frequency is going down and the speed is going down, which is shown by this arrow in this case. And this is something, so if we collect enough data points, we can set up such a map which tells us basically the response of the system to a given state. So we can be anywhere here and we say, okay, if we are in the state here, we will go, the frequency will go down and the speed as well. And then we have here, for example, here fixed points, and here's an unstable fixed point. So we are able to understand the system if we are looking for the drift. And in this talk, I will focus on the drift and not on the diffusion field. But yeah, I think this we can skip for the moment. This is the last slide with equations, so stay with me. Now what we want to do is we have a time series with n dimensions or whatever, and we want to compute these drift and the diffusion term. And the idea is that we have this time series and calculate the increments, and from the increments we can calculate the conditional moments, which are basically the average of the increment to the power of n. So the nth conditional moment is the average of the increment to the power of n at a specific state x. And if we just take the first conditional moment for the moment here, so instead of the n, there's 1. So the first conditional moment is just the average of the increment at a specific state x. Then we basically can cross out this later integral from this formula here. So all that's left is basically this front side here. And the next step is that we want to go basically inside this integral, and this is mathematically way how we can do it. So to calculate the first conditional moment, so if you think of 1 here as the first Kampf-Moyal coefficient is d1, then we can calculate the likeness of tau to 0 of this first conditional moment divided by tau. And with that, like I said, can basically cross out the integral, and all what's left is the d1 part. Of course, this is analytical, and we need other solutions for numerical data. And this is what I want to point out in the next few slides here, really shortly. Just one method how we can obtain these conditional moments, and from there the drift values. So here I've plotted again 2 time series. I simulated these time series x and y, so we have a 2-dimensional system plotted over the time. And what you can see is that these signals are coupled in whatever way, because what you can see is this when this orange variable rises, then also this blue variable is rising as well. And what we do is first plot a scatter plot here on the right hand side, so really the state plot. So for each time step, I just plot the values there, and then we separate these data points into different bins, basically. So what you can see for each red point here, let's keep this here. We draw a rectangle around this point and collect all the data points within this rectangle, and we calculate the average of the increment of these data points here to have an estimation for the conditional moment at this state. And this we have to do it of course for a lot of different grid points, so that we have an idea of the drift field. And what we, in a mathematical sense, what we are doing, we relax this condition here. So instead of looking at one specific state, we look at a range of state. So where we have, like I said, we have relaxed this condition here a little bit. And when we have these conditional moments, this is the last mathematical slide here. I read it once more here. We have this first conditional moment can be described as the alignment of tau to 0 of the first conditional moment divided by tau. And what I've plotted on the left-hand side here is the first conditional moment at a specific state x0 over time lag tau, over the time lag tau. And this is how you can see these, how the conditional moment is changing. And to calculate this drift field, we can select a few data points with small tau values and calculate the slope of these conditional moments. And this slope gives a good estimation for these Kramers-Moyal coefficients. Yeah, this is how we can calculate these drift and this drift fields or these Kramers-Moyal coefficients. And what I want to show you next is really now wind energy specific plots, so that you get an idea what I'm talking about here. So I'm going to show you all normalized values here. So the wind speed and the active power, and the active power is the power outcome of a wind turbine, basically, all normalized here. And here I've plotted these values here. And here, if we focus on this first area here on the left-hand side, what we can see is when the wind speed is going down, also the active power is going down, and then the wind speed is going up again, and the active power is rising again. So which makes, of course, sense. And the same thing on the right-hand side here. So the wind speed is going down, and then the wind speed is going up, and with that, the active power. And this is something what we should be able to see with the drift field. And for the diffusion field, what I have mentioned at the beginning is something like how strong the noise is. This is something what you can see on the top left here, where we have really small fluctuations of the active power when the wind speed is pretty high. And here on the second circle, where the fluctuations of the active power is really, really high when the wind speed is lower. So this is something which we can model with the diffusion. So yeah, and what we have done is basically we took another estimator for the Kramers-Moyal coefficient, not this rectangle approach what I showed to you, or the histogram approach. But we use a linear average cluster estimator, which was already presented last year on a few conferences by me. And basically, we take a time series, plug it into this estimator, and at the end, we have such a drift map. And now I want to explain how you can understand these drift maps. And here, unfortunately, I'm not allowed to share the real numbers of wind speed or the active power. So here on the left-hand side is basically low wind speed. On the right-hand side is high wind speed. Here on the bottom is low active power, so low power outcome from the wind turbine. And then on the top is a high power outcome. And here in the middle, this is a color-coded drift map of the active power. So, and how we can understand this is basically with this reddish area here, yellow to reddish area here, for example, here, if we have high wind speeds, so we have on the right hand side, and pretty low active power, then we have then the active power has a tendency to rise, so go up. And if we are in the bluish area here, then the active power has a tendency to go down, which obviously makes a lot of sense. So this is how we can read these drift map. And we didn't only take one drift map of one wind turbine, but instead we took drift maps of a whole wind park. So we had 100 different wind turbines and could calculate all the drift maps for the active power for the same time period. And as you can see, these different drift maps look kind of similar, but there are some differences, like here on the right hand side, for example, there's a strange wobbling here, or on the bottom left, where also it doesn't look like the one which I showed before. So, and due to the fact that we collected the data of these wind turbines at the same time period, the environmental conditions were pretty much the same, so the response of the wind turbine to a specific wind speed should also be comparable. And this is why we could calculate an average drift map. So we took all the drift maps here, put them on top of each other, and calculate basically the average. And afterwards, we calculated the distance, or how I call it here, the deviation between the single wind turbine to the average drift map. And here on the x-axis, you can see the different wind turbines. So from 1 to 100 roundabout. And we could sort them into 3 different areas. Here where we have the green areas, where we have a small deviation from the average to the average drift map. Here this orange area where there's the deviation is a little bit higher, and this reddish area where we have high deviations. And now we can look at a few examples for these different colors, basically. So here's about 2 of the drift maps which were sorted into this greenish area. And on top of that, I looked at the numbers of service report entries for the current month. So from the month where I selected the data from and the next month. And what you can see here on the left-hand side, for this wind turbine, we had like 4 entries this month and 4 entries for the next month, which is really not a lot. So we can really say there were no issues with this wind turbine. If we look at this orange area here, we have also selected 2 different drift maps, where we have here on the left-hand side this strange map here, or on the right-hand side, this wobbling effect. And what you also can see is that the numbers of service report entries for the current month and for the next month is a little bit higher. So we can assume there were some problems with this wind turbine, which maybe couldn't be detected at this moment with the 10 minutes average data. So yeah. And the last part is obviously the red color with the reddish area, where we have really completely different drift maps here. We have here a strange section on the bottom here, and this drift map there, this was from the wind turbine where there were pretty much no power outcome. And what you can see here is like for this wind turbine, there were 33 errors for this month, so we can assume there were really some big problems which we could detect with our method. So just a short overview of what I've done. I took the temporal height resolved SCADA data, estimated the drift and diffusion for all the wind turbines in the wind park. Because we have comparable conditions and the same wind turbine type, we could calculate an average drift map. And then we needed some metric as a distance measurement of the single drift map to the average drift map, and could determine the different, or we could see if the wind turbine is working in a normal way, or if there was something off. In the next steps, there would be that we have a real two-dimensional field. It doesn't need to be, like I said, the active power and the wind speed. It can be something like in the wind turbine, something like the torque and the rotor of the wind turbine. But it can be, like I said, pretty much any system. And one more thing, so we can also, instead of an unsupervised method, which I present here, we can have a supervised method where we take the historical SCADA data and service reports and log files, can create something like a typical drift map for an error X or an error Y, or something like here in this case where the wind turbine was okayish. Then we take a new SCADA data, calculate the drift map, and can calculate which of these DUF makers is the closest. So in this case would be okay, something like 90% probability that this is an okay state, 3% of an error Y, and 1% of an error X. So this is extendable to a supervised method. So yeah, thank you very much for your attention. And if you have any questions, remarks, or comments, please let me know. Thank you.
Thank you, Mr. Christian Philip, for your presentation. Is anyone having any questions? Okay, no questions, I think. Thank you once again for your presence and presentation.
Thank you very much.
Okay, so our next presenter is Mr. Devganam from Tirthangal Nagar College, India, but I think he has not joined yet as we are running ahead of our schedule. So we will go to the next plenary sessions headed by session chair Mr. Ravi Prasad Ravuri, USA. So I will give a brief description about the session chair. Dr. Ravi Prasad Ravuri holds PhD in computer science in the area of software equality. He has total 20 years of teaching, research, and IT experience spanning across domains like computer networking, database management, mobile computing, cloud, CRM, and production systems. He had initiated and organized several technical symposiums and member of IEEE and CSI. So our next presenter is Mr. Ragad Al-Khattab, Lomi App, Saudi Arabia. Hello, Mr. Ragad.
Hello?
Yeah, I'm sorry. Yeah, Ms. Ragad. Are you ready with your presentation?
Yes, absolutely.
Yeah, just a minute. I'm going to make you the presenter. Yes, it's done. Now you can share your screen with us.
Yeah, 1 second, please. Um, Sorry, but I am using my mobile, so just
Okay.
1 second. Yeah.
Okay.
Okay. Sure. So actually, I'm gonna present Lumi app, and I have my presentation in the back end. I'm not able to show it here.
Okay, you can do one thing. Can you mail the presentation to Suzanne?
Okay.
Yeah, right. I can take in with the Suzanne and share my screen. You can present from there.
Okay. Okay. 1 second, please.
Okay.
Yeah. Did you
Once
get
you
it?
send, once you send, can you please let me inform? Like I
Yeah,
will
it will
take it
send.
from the Suzanne. Okay,
Yeah.
I will take it from the Suzanne. Just allow me a few moments.
Yeah. Sure.
Yeah, I received that one. Now I am sharing my screen. Just
Okay,
let me know if it is visible to you or not.
not yet.
Yeah, just a minute. Yeah, now it's
Okay,
visible.
yes, it is. Yeah.
Okay. Yeah.
Okay, so thanks. First of all, thanks for providing us with this opportunity to speak about Lumi and Lumi as one of the application for the data visualization, data analytics. Lumi app is a mobile application that targets the users who would like to improve their health, their healthy lifestyle and activities. So it is a rewarding application for authentic movement. Next, please. So what's Lumi app? It is actually a mobile app and a platform that offers immediate and intrinsic rewards to incentivize users to stay committed to their goals. So move more, earn more. However, to achieve these results and to be able motivating people to do more or earn more, we need to analyze the data we are collecting through our mobile app. So we focus on a few things to help us tackle the behavioral change behind this activities or this way of living, the healthy life living. So next, please. So our objective in particular is to provide insightful data and analysis for the Gulf area, in particular Middle East and Gulf area users on how to achieve healthier lifestyle based on incidents. So it's not about just we provide a tool or a meaning way or a connect them with a nutritionist or a health practitioner. Actually, we want to provide them with incidents about their behavioral change and to what extent these are beneficial. The incentives that we are rewarding is beneficial for them, and how to monetize it or to help them achieve the a higher level and a next level every time they achieve certain level as well. So next, please. So our method, we have collected data from around 35,000 users registered on the Lumi app, and we're using the app on a daily basis to record their steps and their activities and their even meals and physical activities and goals they have achieved. So we collected the data from 35,000 users from the Middle East area. These data were available for mining and analyzing. Next, please. So this graph shows that users over years they were able to enhance their physical activity and their level of activity as well. The data we were analyzing based on gender, type of activities, time during the day for the activities they have achieved. So not surprisingly enough, we were able to prove that the type of activity, physical activity, has had an impact on the level of activity. So steps and trackers points accounted for the greatest increase in the active days. So our app was built to provide incentives for people based on their steps and tracking their steps. And this is one of the things that we were able to actually prove, that tracking the points and connecting the points or the rewards with the steps was there was a greatest increase for them to achieve more steps during the day. Also, we were able to have some data and some insight about the type of or the gender of the people. So over the years, women were more active than males. However, the objective now is to provide more meaningful way to engage more males. However, over the age of 65, both groups were able to engage and being more incentivized to act or to be active more and more. The other factor as well we were able to analyze is whether doing the activities inside or outside, gym or park, outdoor or indoor. So analyzing the data over the years provided us with more insightful or more proof that behavioral change is taking a more theoretical way than actual way. So to have people actually achieving or changing their behavioral, incentivizing them is one of the things. So the other things could be also working with the private and government to build programs and initiatives to get more people more engaged in the healthy living. So can you please move to the next slide? Yeah. So what's the gap between genders? The relative increase over years was higher in female, at 57% to 89% over the 4 years than males, and increased significantly for all ages, for all age groups. Of course, with the exception of people, as I said, over the 65 group, they were both increasing activities in the same way over years. Next, please. Also, the type of physical activities, as I said, whether it is workout in gym or outdoor activity or steps and tracker points, which what Lumi app provides. This one in particular accounting for the greatest increase in active days. So people were more active during the days where they record steps and track and convert these steps into points and these points into incentives through our network and platform. Next, please. What more can we do with the data that we have collected? So most active period for the day for female and male, and this is something we're now analyzing and working on it to record the exact timing of the day where both where our users are being more active or more physically or taking more steps. So this actually also insight will help if we provide these data for related or people who maintain or works on the trails. So they could benefit actually from these data on to plan on when they can maintain and do some work on the trails. So this type of data, if we share it with government or private sector or insurance companies, will help all the concerned parties that to generate more insightful actions based on these data. Also, the most incentives claimed by users. So on our network, over our network, we have different type of incentives for users to claim. So also we are now able to analyze what type of incentives that users are mostly rewarding for them. I mean, exchange it for their points. This also could help us steer the initiatives in collaboration with other parties, whether they are the communities, the government, the private sector, to steer these activities towards these type of incentives or rewards. And the other thing that we are now collecting data to analyze is what the most common reason the users were behind the user joining the platform. So if it's a certain incentive, if it is a certain goal they would like to achieve, and so on. So we are collecting more and more data as we are moving from year to another, expanding our data and our platform, and having more data to mine and analyze. There are so many potential things for us to include and to analyze. Also, from the perspective of meals, eating habits, activities, age group, or even community-wise. So we are collecting very insightful data, and we are on a goal or in a mission to provide really insightful data for our partners to be able to build or steer their initiatives, their programs, their incentives to help the coming generations to be more active and more live more healthier. Yeah, next please. So the findings of these data supports the correlation between the rewards incentive model and the increase in people adapting and sustaining active living lifestyle. This is also something there are other researchers and other studies that have similar conclusion, and they reach to this correlation between the rewards or the incentives. The challenge now is whether these incentives or rewards keeps the users active enough for a long time, or it's just a momentum. They start, they collect certain rewards, then they may stop, or they may back again to their old habits, and this is something we are analyzing or collecting data for through providing different incentives each time of a year, or different types of rewards for different type of people or group of people. So these data will help us further develop the platform, the network, the application as well, and to what extent we need to record and track their activities and their physical activities, their every aspect of the healthy living. I mean, even the well-being, the eating habits, the physical activity as well. So we are on a track to analyze more, to collect more data, and to provide more features and further develop our platform network and have more ability to influence the users who are joining the application. So if there is any question, I am more than happy to answer.
Regina, quick question.
Yes, please.
You said data were drawn from registered users, right? Through the app.
Yes.
Okay, so like what are the criteria to get the data from the users? Like which criteria you used?
So you mean in terms of collecting the data on our application?
Yes.
Okay, so when users joins the application, we do collect some basic information about their gender, their age group, their objectives. And while they are using the app, we record and track their physical activities. Of course, we do have their consent to do that, to collect these data. And the purpose is to be able to analyze and provide each and every user with what's most suitable approach for them. I mean, if I find some users are more motivated with outdoor activities, then I will provide them with incentives that fits that type of lifestyle. Some other people are more motivated for indoor workout, then we could also steer our incentives for them based on that. So the criteria is just to collect what um, certain basic information, and while they are using the app, and if they are working with a healthy nutritionist or a healthy practitioner, then the healthy practitioner also will be able to analyze further their specific and case, I mean individual case. And these data are not collected on our database in details. It's just with the practitioner to be able to analyze and provide insightful or a map for the user to achieve their goals. Did I answer
Okay.
your question?
Yeah, I got it. Thank you.
Yeah.
Good one.
Thanks.
Appreciate your efforts. Thanks.
Thank you.
Okay, thank you, Ms. Regard, for your answering the question. Is anyone else having any questions? Okay, no questions, I think. Thank you once again for your presence and presentation.
Thank you for having me, and it's wonderful to be here. Thank you so much.
Thank you very much. As our next presenter is Ms. Aparna Dinakaran, I think she has having some important work, even the Mr. Muhammad Shalan also. These both cannot join us with us today. So we requested them to present tomorrow. So by this, we came to end of our day one webinar. I would like to thank to all the attendees and participants of today's webinar. Hope you enjoyed this and gained some knowledge from the sessions. Yeah, hello. And request you to attend the tomorrow's sessions as well. Thank you. Thank you once again for your presence and making the
Thank you.
webinar successful.
Thank you.